The broadcast is now starting. All attendees are in listen-only mode.
Hey everyone, I'm Martin from JetBrains and welcome to JetBrains.net Days Online. We have 2 days this year, just 1 day last year, and I want to thank everyone for joining us today. With us here we have Zoran Horvat, who will be refactoring to patterns using ReSharper. I'll let him introduce the topic himself, but before we go there, let's cover a few practical things first. If you have any questions during the webinar, feel free to ask them in the questions pane. We'll try to answer questions as we go along, and I may ask Zoran some questions at the end of the session. There are over 1,000 people watching right now, so we may not be able to cover all questions, but we'll try our best. But do feel free to reach out to the speaker afterwards on Twitter, and I'm sure he'll share his contact details as well. This session and all other sessions these 2 days will be recorded. So if for some reason you have to drop off or you cannot join a particular session that you wanted to see, you can always check out the JetBrains TV channel on YouTube in the coming days. But of course, we would love it if you could be able to stick around. With that, let's switch over to Zoran for some refactoring goodness.
Hello, everyone. I hope you're all doing well. And thank you for joining my session. Today, I will talk to you about refactoring to design patterns. So, the question of refactoring to design patterns is very important because I see that many people are making mistakes about both refactoring and design patterns. So today I will show you a couple of slides to tell you the backing theory, why we use design patterns, when do we use them, and when do we refactor. And after that, we will switch to code, where I will show you one demonstration how design patterns can appear naturally in the design and how refactoring is used to help reach the design which is applying patterns correctly. So, the design patterns, when you work on whatever requirements you have, you will normally produce some code, and many people tend to introduce design patterns right away. They read requirements and they apply patterns. They transform requirements into patterns. And as you will see during this demonstration, the mistake will already be made at that point. Because my question always, when it comes to design patterns, is what patterns? Which patterns do you see when you read requirements? Because your customer will never ask you to apply any particular design patterns. They will ask for a piece of code which works. So I'll give you an example, an abstract factory. Why do you want to have an abstract factory in your code? You see, you have the client which is using an abstract product, applying an abstract factory to construct it. Behind the scenes, there will be a concrete factory injected, which is creating a concrete product. Why do you want this? Especially, why would you want to have this if you know that talking to an abstract product is by definition more complicated than talking to a concrete product? For one thing, abstract product will certainly miss some details of the concrete product. So why do you want to have it? It will complicate your design. For example, virtually all books on design patterns are mentioning this example, a GUI factory, a factory for graphical UI elements. You want to have a button, an abstract button. But if you are working on a Windows system, you will work with the Windows button. And then if the client wants to really work with a Windows button, it will eventually need a window handle. But the window handle doesn't belong to the abstract button. That is what I said previously. It becomes hard to talk to an abstract product. So the abstract product will now have to accompany a cross-system abstract handle, which will have a concrete Windows handle below on your concrete Windows system. So why do you want to have such a complication in your design? Why 7 types if you only wanted to have 2 types to work with? That is the curse of design patterns. They are inflating your design. You don't want to have them before it is certain that you will get the benefits a pattern is offering. So the benefit of an abstract factory is to support 2 distinct products. So the question is, do you have 2 distinct products, and is the abstract factory the right way to produce them? If yes, then you will either see this or this, and then you will have some flexibility. This pattern is promising. The question is, again, do you need this flexibility? And then, why abstract factory? If this is the flexibility you need, then I will tell you straight, there are a couple of options there besides abstract factory. I will give you an example from the project which I'm working on these days. It is about editing sound. When sending sound to some device, you have some options like saving it to a file, or sending to a network service, or playing it on speakers. That is where abstract factory can be injected so that it can create one or the other concrete sound device without the client depending on any of them. So that is good. But again, why abstract factory? This is one option. What if this sound device was an isolated concept? Why not a factory method? Or why not injecting a strategy so that the client doesn't even see this object here? So there is no connection here. The strategy could create and use the sound device, concrete sound device, and that's all. So the client doesn't even see the product. That's a completely different mindset. Or why not turning the client abstract and implementing concrete clients with their own save methods, which are producing and using sound devices, again, making sure that the abstract client doesn't see concrete or abstract products. So you have at least 4 distinct patterns to apply here. If you read the user's requirements and apply one particular design pattern, you will get the flexibility offered by that pattern, but you will lose all the other flexibilities that are cut by that particular pattern. And you may have made a mistake because you still haven't reached the point in your design when you do need flexibility. And what if it turns out that the flexibility you will need in a week or in a month is not the flexibility you have just injected into your design? You will have to write it all over again. Let me show you again an example, this example with sound, and I will show you code which demonstrates this line of thinking. You will start with user stories, supposedly. So the user will want to compose sound, and you will write a piece of code, which is, I don't know, producing sound. And you will want to debug it. You will want to save it to disk as an uncompressed. You don't want to complicate your code. You just save a wave file and listen to it. You don't show this to the customer. This doesn't go to production. But you have one feature implemented. Then comes the next user story, which says, I want to save sound to disk. And then you say, now observe that on the right side where there is code, there are no design patterns. You don't need them. Nobody has asked for any special kind of flexibility, so there's nothing special to do with the design. Just implement what was asked. Okay, so the user wants to save sound to disk. But you only have the raw sound, which is uncompressed, and you must compress it. So now you add a feature, and the file name will not be the wave file and will not be the debug wave. Somebody will have to tell you the file name, and that becomes a parameter to the algorithm. So a very important thing that many people slips from many people's minds is that you can make your design flexible by using parameters. You don't need any patterns or any special design elements, just pass the parameter. And you can make this implementation flexible enough by only parameterizing its function. And then comes the next requirement. The customer wants to hear the sound. So it's not to save it to disk and play manually, but wants to play it while editing. So you will add the play function, but play on what device? You need to identify the device on your system which will receive the sound and play it. And now we see that something strange is happening. We are having two kinds of parameters. And that is the place where parameterization ceases to be useful. And then we jump in and implement a design pattern because we have two kinds of behavior which cannot be put into one class. And then we think, which design pattern? Is this sound editor a reusable component? Or is that sound device, whatever it is, the file on disk or a media player, is that a reusable concept in your design? If it is, you might think of using some kind of factory. Then, is that device an isolated concept? If yes, then just pass in a factory method, or if it is part of some larger bundle of classes, then use abstract factory. Otherwise, if it is not reusable, if this editor is only going to save or play the sound, then we could think of some kind of a strategy. Is this sound editor doing only one thing? If yes, then you can use the template method. If not, then inject the proper strategy into it. What I want to tell you is that you can see that this thinking only came after quite a large body of user stories was already implemented. I never needed any kind of special flexibility here, so I didn't apply any design pattern. But when the troubles came, then I had a lot of information about the way the application will be used and about my particular design, which I have right now. And then I can apply some thinking, some qualified thinking to apply a design pattern which is just right for my situation. That will increase my chances of survival later when a new requirement comes, like the user wants to send sound to an online library. Okay, how will my new design, with whatever design pattern I applied, will survive this? Well, if I was right, then it will only mean that I will add one component to the design and nothing else will change. If I wasn't right, then I will have to redesign the previous solution to make it possible to add a new component to it, the new concept to it. So basically, you are applying design patterns when you have information what kind of flexibility you need. And once you clear that, you will probably have one or two design patterns which are natural candidates for your design, and you will simply apply them. If you were right, then subsequent requirements which are how to say, which make sense in relation to previous requirements, they will naturally fit into your design. If you were not right, you will have to redesign your application and start some parts of it again. Okay, that was a theory. Now let me show you some code. I will, in this demonstration, develop that sound editor, which is following a bit modified requirements, a bit different compared to what I just shown you because I want to make it more interesting. But the first requirement remains. The user wants to generate some sound. And you would do whatever that means. You can imagine 7,000 lines of code behind this line, but in the end, a couple of weeks later, you will have a sound generator, whatever that was. And as I said, you will want to probably hear it. So you will add save for debugging, a hidden method which will not be deployed to production, where you will save the sound into a debug.wav file, which nobody will see. Only you will be able to see whether the rest of the application is doing well. But this is the entire first requirement. Again, there are no design patterns here, except maybe in this implementation, but I'm not interested in that right now. Anyway, we are done with the first user story. The next user story is to save sound to disk. So I already have something similar. I will rename it to save. You will see that I will be using ReSharper all the time during this demonstration. I will use many features of ReSharper as promised in the title of this talk, but I will not talk too much about those features. I hope if you're using ReSharper or any other tool that you will get the point of particular refactorings I'm applying. Anyway, I have some save method, but that will have to compress sound. It doesn't make sense to save the WAV file to disk, so I'm adding new feature. Observe closely what is happening to the code. Which pieces of code I'm adding and which pieces of code I'm modifying. Because as a programmer, you never want to modify code. If you modify code, you will add bugs. You will introduce regressions, things that used to work will stop working or will start working differently. People will get annoyed and stuff like that. You know that. So you don't want to touch code which was designed well and implemented well. But right here, I have to modify my previous implementation. So I will invoke compression. This debug wave file will have to go. You see, it doesn't make sense to tell where to save the file, but I need some parameter. And I will add a property to the sound editor. So the sound editor will be destined to write sound to one particular file. Destination will become a parameter of this object, and it will be set through the constructor. And then I will effectively write to that destination, all right? But I had to change both lines of code. So whatever logic, whatever domain logic was here, I will have to modify it. And that is the dangerous part when you have a new requirement and that requirement fits right into the class which you already have. Then you are in the danger zone. You will make bugs, you will make problems. But all right, that is part of our life. We have survived this, and this requirement is done. But then comes a much more complicated request, and that is to play the sound. That is not compatible with this implementation. We'll have to come up with something new. So I will introduce, I'm still in the same class, you see. I'm adding a new play method. Not just save, but now we have two behaviors with the uncompressed sounds. The same state is being transferred to two distinct processes. Remember that this process save was already parameterized at the object, at the class level. The object has the parameter, but this one has its own device ID. Why? I want to unify these designs, so I will expect both play and save to have their particular parameters in this object. And now we have two incompatible behaviors. That is where parameters will abandon you, and you will have to think of a more flexible design, a different way to inject behavior. So I will retain this idea of holding the parameter as part of the object. But then, since I have a file info as one parameter and an integer device ID as another parameter, it looks like I will have to have two classes, one with file info and the other with integer. So I will derive a class. And I will call it File System Sound Editor. It will do what my classes is currently already doing. So I'm pulling behavior down into a derived class. How do I do that? I will, what I said, pull behavior down in ReSharper terms, that is pushing behavior members down. I will push this save behavior down into this derived class. And since I already know that playing will be just a different kind of this behavior, I will make it abstract in the base class. So you can see that I'm refactoring in such a way that I'm already supporting adding the play function, but in a different class because it pulls its own parameters with it. Save will require compress, and it will require destination. So let's see. Okay, it's warning me about some things. Save will become protected. I'm fine with that. And destination will be a problem because you will see what will happen anyway. Destination is now a parameter of the base class, but base class should really not depend on it. I will delete this constructor and initialize destination here in the derived class. What happened here is that now I have all that behavior which I used to have in the sound editor, the only sound editor class, but now it is encapsulated in a derived class which depends on its own parameter. Save method has become abstract in the base class. I will make its name more abstract too. I will call it persist. Not too smart, but I don't know. In a sense, it doesn't promise to save sound anywhere. If you don't like any name, don't worry about it. Renaming it again will be another 3 seconds of your life, so don't worry about names too much. Anyway, play function will be just another implementation of persist, so I will delete it from this class. This class will only have the persist step. I will move this file system sound editor to its own file. And let's see what we have got. We have an abstract persist method on the base class, which is used as one step in a larger algorithm. What is that? It is the template method. This function, this method, is a template method. And concrete implementation of one step in the template method is this. Did I have to mention the template method design pattern while doing all this? No, I didn't have to. Do I have to use that name right now? Maybe, if I wanted to make me more clear, because you know the template method design pattern, and I don't have to explain you how this method is going to work. But that is all. Besides improved communication, I don't see much value in design patterns. Honestly, if you insist on design patterns too much, you will probably fail to see other elements in your design, and you will probably make more mistakes than if you just didn't think about patterns at all. So what I effectively did was to pull out a few members, to fix a few mistakes, to make sure that I didn't break any of the classes. So this was a dangerous move. That's what I want to point out. But in the end, we have a design which is more flexible than it was. Before, it was parameterized through the constructor of the only class. We have hit the wall there because the second incompatible parameter could not be injected. So we moved that parameter to an object. And now we can implement a different kind of a sound editor, and that is the player, which has the device identity, a different incompatible parameter. And now we implement that abstract step in the template method any way we like. Again, you can imagine a few hundreds of lines of code here. But after, what I want you to see, that after I created the template method and one concrete implementation, adding the second concrete implementation was a piece of cake. Nothing else in this solution changed by introducing another concrete implementation, another concrete derived class. And that is the benefit of not just design patterns, but of the design. When viewing any design pattern, you're actually trying to see a single important element it is adding to your design. This application of the template method pattern is adding independent parameters to my design. That's what I needed, and that's what I have now. It is closing the door for many other things, and one of them you will see in a minute. The point is that any design pattern you choose to add to your design will make it better in one respect and worse in all the other respects. So, the next request. A user wants to be able to add a segment of sound to whatever he is editing. I will, for example, add silence, because when producing sound, users want to add a second or two of silence at the beginning and the end, and a real sound in the middle of that. Now, that is completely different compared to what the previous request was. I mean, the previous request was to add the entire sound, and it was very easy. If you go to File System Editor, adding the entire stretch of sound means just to write all bytes to disk. That is very simple. Now, if you have some knowledge about sound files, you will know that you cannot just append bytes to a file on disk. It will simply not be all right, because sound files have headers. They may be compressed in a way which must be decompressed and recompressed again if you are adding parts of the sound and stuff like that. So it's not so easy. This request in my application is quite different. And there is another important element in this request. This add silence will be invoked several times. Generate tone was supposed to be invoked only once, but this one will be invoked several times. So now you can imagine using the application, using this class this way. Add silence, then generate tone, then add silence. There is a time protocol, and that is what you will often hear it to be named as the protocol. When you have a protocol of using some specific class, then you have much wider range of problems compared to using a class with only one operation, which is called only once. You will have a long living object, and you will see the template method will not be able to support that. But we still don't see it. We might say, oh, this previous design worked so well for us. Let's add the append method. Let's construct another template method and simply append silence to whatever device we are using. The problem is that this simply won't work for the reasons I just explained. You cannot just append bytes to a sound stream. It won't work. We need something better. And when you need to support a protocol, you will probably need a subordinate object which will support the part of the protocol you need. And I'm speaking abstract right now. I'm not sure whether you can follow me, but if okay, let me try to repeat it. This sound editor must support a time protocol. It cannot support time protocol because it doesn't know what device it is talking to, because every device will work by following a different kind of protocol. And so it will have to pass that duty to somebody else. When you say somebody else, that is another object. It is not a derived class, because a derived class will share the same issues this class is already having. I want this append to be defined on some other object and let that object manage the protocol alone. Okay, so append will be defined somewhere else. It will not be an abstract method. I'm doing this refactoring this way because that is how ReSharper will help me do it. It's not necessary. You can do all this manually. It will take a few minutes more than what I will do right now. So I will turn the append method non-abstract. I will extract a class, and I will call it file system sound sync. It will be a sync for the sound. It will just receive sound from me, and I don't know what it will do with it. But what happened here is that now I'm calling append on something else, on an object. I have pulled out an object. Okay. But I don't want to talk to file system alone. I want to support different kinds of sound sinks, like speakers or headphones or network connection. So I will, in fact, extract an interface and call it an iSound sync. And I want this interface to have this method on it. Here it is. This is the abstract sound sync, which will supposedly support appending sound to it. Then I don't want my sound editor to depend on a concrete class. I want to use the base type, not object, but sound sync interface. Here it is. And I don't want this to be the field. I will encapsulate it in a private property. Here it is. I have completed this refactoring, and now comes the next step. This file system sound editor will be promoted to a sound sync. It will be following its own protocol about compressing, decompressing, doing whatever stuff needs to be done. So I will eventually make it implement that interface, not derive from the sound editor. So I want to have this sound sync to be initialized to a concrete instance of the sound editor. But I cannot do that because you remember this sound editor requests a file info and I don't have it. We are missing a mandatory parameter here. So we will have to do something else. Template method will not work anymore for us. I will delete this class. It was only used as an intermediate step to help derive this interface with the only method I wanted to have. So I have completed pulling out the sound sync concept, but my code doesn't work. Instead of instantiating this sound editor component, I will choose to use the factory. Before that, let me clean it up a bit. It will not be the sound editor, it will be audio file. It will be just a file. It will implement the sound sync interface. So to remind you again, remember when I said that when applying a new pattern, you will have a part of a stretch of time when you are modifying code, exposing yourself to danger. Well, this is that period of time. I am elevating one class to do something more than it used to do because it doesn't support the new requirement. It cannot be used as part of the design which is implementing the new requirement. So I am in danger right now. And I must think how to modify this class, how to augment it with minimum of changes made to the substance of it. This is the substance. This is those 7,000 lines of code. I must not touch it as long as I can sustain not touching it. Anyway, this method persist will become that append method. And then I will have to change these things. This stretch of code will be affected by the new not refactoring, redesign. So now I will be really in danger. This will simply not work when working with sound. I explained that. But once that is done, this class will support appending uncompressed sound to an existing stretch of sound. But now that it has a time protocol built into it, it will have to be disposable because it will not just write, it will write many times to the same file. It will hold a file handle open, which augments the design even more. The sound sync will say that it is disposable. You see, this will affect the one who uses that. The sound editor is using it. So now it will use the disposable component. It will complicate it even more. But anyway, I will implement the dispose. It is empty now because I'm just pretending that I am appending anything to the file. And this class will effectively be done. I have augmented one element of the design. This audio file, which used to be a file system sound editor, is now a separate concept, not deriving from the sound editor, but doing something completely different. It is effectively offering a strategy to append sound to an existing sound. And now is the time to apply a factory. So the sound editor will have to receive a factory for this. And when it comes to using it, it will have to instantiate the sound sync if it wasn't instantiated already, and return it so that the append can be called on it. This time you can see that I'm using this append as a strategy effectively in a larger algorithm. Writing the entire or generating this tone will also append that tone to the file. That's all right. This persist method will not exist anymore. And now comes the second part of editing the sound editor. For one thing, it will not be abstract, but it contains a disposable component, so it will have to be disposable. I will implement dispose. If SoundSync was effectively used, it will have to be disposed. And this completes the redesign. There is another component. You remember this sound player. It will have to pass through that same torture, becoming a kind of a sound sync, penning sound in a probably different way, and disposing of it at the end, like closing the device which it was using to play the sound. Anyway, I have completed not only the refactoring, but a pretty large redesign. And all that for the sake of supplying this new method. I simply had to do that because the previous design didn't support it. And that is the curse of design patterns. When I applied the template method, I was probably right to do that. But as you can see, the customer came with a completely different requirement that wasn't perceived upfront. They asked for a different kind of a feature, and my design didn't support, wasn't flexible in that design. So what do? Well, you spend a week redesigning a part of your application. Good news about that is that if you were designing your application, your code in a decoupled manner, if your concepts were already isolated and decoupled one from the other, then the redesign you will have to apply will probably be located in a small piece of your application, not application-wide. So that is one good thing that comes from design patterns, even if you make a mistake. And the second thing here is that that danger zone you will have to pass through will be smaller, because you will probably try to find ways to augment one class or two classes or one interface and a few implementations of that interface. You will not have to augment the entire design all at once, because that might take a month. But you will be able to work in smaller steps. You could, if you have a large design with 1,000 classes, and maybe 100 of classes will be affected in the end, you could start bottom up, augment one class after another, one interface after another, with minimum disturbance to everyone who is using those, and then progress your change through the design until maybe in a month you have augmented the entire design, but in very small steps, much safer steps than if changing 1,000 classes all at once. You will probably be able to release your application several times in that period. And in the end, you will have the augmented class. If you read Martin Fowler's book on refactoring, you will certainly know that Mr. Fowler is using one word very often, that is the word seam. You should add seams to your design. Those are places where you can inject new behavior, pull out a method, pull out an object. That is exactly what I did. And in particular, template method has offered me a seam, and I didn't plan to do that. It simply happens. Why did it make that seam available to me? Because template method is decoupling the large algorithm from one particular step in it, and that step was the seam. And injecting the protocol was in effect done by pulling out that seam and turning it into an entire object. So this was, again, a lot of theory, but that is how design patterns and design elements of those patterns are working. I will complete this presentation by simply showing you how this editor can be used on the client side. I want to instantiate the editor by newing it, but I cannot because it is asking for the factory. All right, I will prepare a factory, a func delegate, which is just instantiating the audio file. Now you see that connection between the sound editor and the abstract sync, but not with the concrete sync. This editor will not know that it will effectively save a file on disk. However, this audio file is requesting the destination, the location of the file. So I will inject file info into the audio file, but not into the sound editor. And now we have that decoupling. So when we put the sync factory here, there is no connection, there's no dependency of this object on this one object. And you will see how I will use that in a minute. Anyway, sound editor is now disposable. If you used sound editor before append was added, now you will have to modify the client as well and to put it into the using clause because it has become disposable. That is the problem with redesigns. You're breaking clients. You're breaking clients sometimes in ways that are not easy to spot. If I forgot to dispose the sound editor, maybe no tool will issue a warning to me, and I might deploy this code to production, and it will not work well. You will see why. So if I instantiated the editor, I could add 2 seconds of silence, add some tone, add another 2 seconds of silence at the end, and dispose of it. If you remember the design, disposing of the sound editor will trigger disposal of all the resources effectively used under it. In a way, if I saved that to a file on disk, that sound will be encoded and written as MP3 on disk, and I will be able to open that file will be unlocked on disk after dispose, and I will be able to open it and listen to it. That is how my design is working now. But what if I wanted to hear it while editing? No problem. Just change this, nothing else. The editor cannot see the change because, again, it is not coupled to this 0, which is probably a default sound device on computer. It is not coupled to that. That is a private property of this class. And I suppose when this dispose is hit, I suppose that will finalize pushing the sound to the sound player on my computer, and although all the resources here will be disposed of, I suppose that my speakers will play the sound for another half an hour or whatever. That is the protocol. This sound editor is not bound to. That is what I want to explain. So this use of the class, which incorporates several design patterns, will not be changed through the lifetime of my project. That is the benefit of design patterns. Okay, there was a lot of code here. I hope that you have followed through. I have left 10 minutes almost for your questions, so you can ask whatever you like. Martin will send and ask the questions now, If you wanted to know more about design patterns, I have 5 courses published, 2 of them on Udemy about design patterns and refactoring to patterns. I have 3 other courses at Pluralsight, total 25 hours of video courses. So if you wish to learn more, be my guest. Now, your question, it's your time.
All right, Soren, first of all, thank you for a very, very interesting session. As promised, I will send you the questions on the private chat that we have as well. First question that I got from people is for doing all of the code snippets during your presentation. Is that your Visual Studio extension you're using?
Yes, that's my Visual Studio extension, and hopefully it will it will be less annoying in the future if I get some time to improve it. Thank you.
All right, perfect. The next one is, how does all of this relate to using solid principles?
Well, if you take solid principles, refactoring principles, design patterns, you will see that they are speaking about the same set of things. That is why I rarely ever name design patterns, because it's not the design pattern that matters. It is that single or those 2 or 3 principles it is applying to your design that matters. So when choosing the design pattern, you will choose the pattern which is improving your design in respects which you need. If you need any of those solid letters, if you're lacking it in your current design, then you will effectively uh, apply a design pattern which is improving that aspect of your design. Uh, Most notably, design patterns are improving flexibility. They are turning one thing from your design into an object, invariably into an object, and then you inject one object or the other to vary behavior. Sometimes those objects will implement interfaces. You will sometimes segregate interfaces, but invariably you will decouple one piece of code from the other by injecting some objects. And I don't know, if you remember any, I don't want to make this answer too long. If you remember any particular principle from the solid, from explanation of solid principles, you will see that in many design patterns. That's what I want to say.
All right, cool. Another question was on that sound editor class. Why are you depending on a SoundSync factory instead of only using the iSoundSync?
That is an excellent question, and thank you for asking, because I have forgot to explain that. That is an important aspect. You use factories when you want to control the lifetime of an object. If an object is locking resources, but you are not certain that you will effectively need them, especially if that object is disposable, you will probably be better off to send a factory rather than an object itself. Particularly when speaking of disposable objects, the one who creates it should be the one who disposes it, or otherwise those 2 pieces of code could go out of sync, and you might forget to dispose disposable objects. So it is safe. It is a kind of safe programming technique to dispose, to let the one who is instantiating an object dispose that object. If that object, like this sound editor, is using the disposable resource over its entire lifetime, then it becomes disposable too, and disposes the disposable resource in its own dispose. So disposing becomes transitive. If sound editor received the sound sync, then it wouldn't dispose it. But if you remember, it created, it invoked the factory only on first use. And that could be a few minutes later. So you don't want to lock the file on disk or to establish a network connection before you effectively start sending something over it. That is the reason why I use the factory.
All right, cool. Thank you very much. Then more of a philosophical or personal question, I guess. What's your opinion on using composition over inheritance while building a first iteration of your design?
Yes, I like composition a lot, but it is making the design more vague, more hard to comprehend. On the other hand, derivation is good as long as it is limited. If you start deriving at 2 levels of depth, you will probably have a wider range of problems caused by the appearance of the second level of inheritance. I have an entire talk on inheritance versus composition, so you could watch that. The short answer is, if you are inheriting only one level deep, you will probably be able to get away with it with nobody really noticing that you have used inheritance, and without incurring uh, the problems of inheritance on the callers. When you start making deeper hierarchies, inheritance hierarchies, you will probably begin making problems to your callers. Again, watch that talk. It is going in great depths what happens when you inherit and what happens when you compose objects.
All right, cool. Then a more practical question from a lot of people actually: is the demo project that you used available publicly somewhere on GitHub or on your website?
I will put it on GitHub. I will do that in another 1 hour, so you can find me on GitHub and look there. It will be there.
All right, perfect. Maybe one more question before we wrap up, and that is related to the design choices that you made during the presentation. Would you do big changes if you want to do both things, like save and play with the same sound editor?
Oh, yes. Well, that would have to, uh, if you start thinking about how to do that, then you would have to add more details to your request. What does it mean? Does it happen simultaneously? If yes, then that is a very simple thing. Then you make another sound sync, which is just receiving 2 sound syncs and passing every call to both of them. But if there is some more complicated protocol, like playing until something happens, like this pose, then passing everything to the second one, then you will have to implement a special sound sync, which is implementing that protocol. But again, it's all about protocols. In programming, you're always looking at the lifetime of an object and what responsibilities it will resume during that lifetime. If one object is doing one thing, it will probably mean that you will call one method on that and be done with it. And that is great. You always want to have that. But if you have a protocol which supports multiple invocations, and sometimes those invocations depend on each other, like it's not possible to pass sound without specifying how long silence it should be before, then you will have troubles. So stay away from time protocols as long as you can, and when you have no other choice, then use a bigger hammer and implement them. There is no happy path there.
All right, cool. Yeah, maybe one more. I guess we still have a couple of minutes, right? Aside from adding automated tests to this project, what could you do to reduce the danger zone even more?
That is a good question. Again, you are reducing danger zone by reducing your classes. If you have a class with 20 lines of code, then you will probably not make a mistake when changing it. If your class has 100 lines of code, many functions calling each other, then you will be in much larger danger. So if you can focus on doing one thing per one class. And if there are a couple of things to do, then making another class which is receiving through composition another couple of objects and passing calls to them in specific order, then you will have a bunch of small classes, and it will and your change will only affect a couple of them, not all of them, probably not all of them, you know, and you will be in much better position to make the change, a large change, in small steps without causing much trouble.
All right, perfect. Thank you very much. Yeah, I guess we can wrap up here and switch back to my screen. Thanks
Thank you
again,
very much, Mike.
Zoran, for a very interesting session. I think we could host you every day in terms of sessions.
I'll be glad. Invite me anytime you want.
All right, here we go. So thanks again, everyone, for joining us today. The next session is going to be by Andrew Karpov, who will start in roughly half an hour from now, which is going to be a deep dive into async streams in C#8. We'll see you there, and thanks again for joining this one. All right, I know a lot of people are still around. We're going to do a very quick tech check with the next speaker, Andrew, who is online here. Andrew, if you can unmute.
Okay.
All right,
Can
perfect.
you hear me?
Yep, we're going to quickly switch to your screen, and if all that works, we'll go back to mine, and then we can start in 15 minutes. Yep, that works. That was a very quick one. Thank you. All right, here we go. Welcome everyone. I'm Martin from JetBrains, and welcome to this JetBrains.net Days Online. With us today, we have Andrew Karpov, who will be doing a deep dive into async streams in C# 8. Before we start, I want to quickly go through a couple of practical things and then let Andrew introduce the rest of the session. So first of all, if you have any questions during the webinar, feel free to ask them in the questions pane. Do note that we will try to answer the questions as the session is going on, and I may ask some questions at the end of the session that Andrew is presenting. The thing is, we have 1,040 attendees right now, so Andrew did not want to hear that, now he knows. We have 1,040 attendees, so it means that we may not be able to answer every single question that comes in. So please understand if your question is not being handled, but do feel free to reach out to the speaker afterwards on Twitter or through the contact details that the speaker provides. This session and all other sessions will be recorded, so if for any reason you have to drop off, you can always check out the JetBrains TV channel on YouTube in the coming days. But of course, we appreciate if you stick around. With that, we're going to switch over to Andrew for some async goodness. And Andrew, I think you still have to unmute. Andrew, can you unmute maybe?
Yeah, okay. So thanks Martin for introduction, and hello friends. So my name is Andrew Karpov, and I work as a software developer at JetBrains, where most of the time I'm working on C# support for ReSharper and Rider. About a year ago, as part of my job, I implemented support for C# 8 feature called async streams. But as times go by, lots of important things happened. Most notably, C# 8 was finally released and people started adopting new language features. So I thought this event is a great opportunity to look back, see what's changed, complete some unfinished tasks, and, share some experiences. And let's start. And the first part is exploring diversity with effects. So all applications in some or another way interact with data, and the kind of data and application requirements usually define the most appropriate way of interaction. And whether we should use pull-based model or push-based model. Intuitively, it must be clear that if we need to load some data on demand, piece by piece, then probably pull model is a way to go. And in contrast, if we are dealing with data representing some sorts of events that our application need to react to, then it makes sense to use push-based model. But let's just look at some code and start exploring the diversity of pull and push APIs. At the simplest level, we can express pull-based model as a function without parameters that returns some data of type T. But how many insights do we have by looking at this signature? Well, not much. Clearly, the signature doesn't tell us about all possible outcomes. So let's make it more precise by sprinkling it with effects. The first effect we're gonna cover is graceful termination. It means that we pulled all the available data and should stop calling the function. And we can express this effect by using the option of T return type, which models either having some value or absence of it. The next effect every C# programmer familiar with is exception. This effect means that some error occurred and we can get the results. C#, unlike Java, has no checked exceptions feature, and for great reasons, actually. But for our purpose, we would like to make this effect explicit. So we would convert control flow to data flow and use another wrapper type, try, which expresses either having a value or exception. Now we made our signature super precise, but where can we get this function? As you may know, any problem in computer science can be solved with another level of indirection. That's a fundamental theorem of software engineering. One way of providing the indirection is using higher order function getPooler, which would return us the desired delegate instance. But we actually like object-oriented programming as C# programmers. So we put our pool method into iPooler interface and introduce one more interface with single getPooler function. Do this in
Andrew, I think your
decomposed.
microphone cut out for a sec there.
Yeah, so
Yeah.
can you?
You're back.
So it's a well-known type, IEnumerable and IEnumerator, but try of option of t is decomposed here into method moveNext and property current. So what does this mean? It means that IEnumerable is the essence of pool-based data access API. Now we're gonna apply the trick that I learned from Eric Meyer and apply duality. In mathematics, duality translates concepts, theorems, and mathematical structures into other objects. By means of special involution operation. But when applied to function signatures, involution simply means swapping of inputs and outputs. So in our case, from super precise pool function signature, we get the push function taking a single parameter of type try of option of t and returning nothing. As previously, let's introduce another level of indirection and apply duality there. As a result, we get another two interfaces, iPushable and iPusher. And these interfaces should also look familiar. It is iObservable and iObserver from Reactive Extensions library. And just like in case of IEnumerator, try of option of t is decomposed, but now into three methods. So what we've got so far, so iObservable is the essence of push API and has deep mathematical relation to IEnumerable. They are dual, and it is possible to go from one interface to the other. But we forgot another important effect, latency, which tells us that function may take a long time to execute. There are two problems related to latency when working with interfaces that we've just discussed. The first one is problem of slow producer when calling the moveNext method on IEnumerator blocks the execution. And another slow consumer problem when the execution is blocked on next, on completer, and on error calls on iObserver. To solve these problems, we're gonna mix some asynchronicity into our interfaces. And in case of IEnumerable, apply an asynchronicity result in iAsync enumerable and iAsync enumerator, with a notable difference that move next now returns task of bool instead of just bool. And in the second case, we get iAsync observable and iAsync observer with on next, on completed, and on error now being task returning. Let's put it all together. So I came up with the following graphical representation of types, the prism. So if we need to return fun values synchronously, we just use the T return type. If we return many values in pull manner, we use IEnumerable, and in push manner, we use IObservable. But if we need to take latency into account, then we respectively use task of T, iAsync enumerable, and iAsync observable. Where are the async streams on this figure? Actually, there are three of them: IObservable, iAsync observable, and iAsync enumerable. They all employ asynchronicity, but slightly differ. We have diversity of types, each representing some combination of effects. And when designing our applications, we should choose accordingly to the desired effects instead of sticking to some particular type. What's interesting is that prism doesn't look like a complete puzzle, and we may consider extending it to the cube. What's on the other side of the cube? We're going to talk about in the end of the talk if we have enough time. Now, where to find these interfaces? Actually, they exist, and for a long time already. So iAsync enumerable was part of interactive extensions since 2009 or 10, and iAsync observable is also part of async RX and located in .NET Reactive repo. And there are a couple of F# implementations too. But what's important for our talk is that since .NET Standard 2.1, iAsync enumerable and related types are now available in base class library, though there are some subtle differences from what we've seen so far. For instance, getAsync enumerator takes optional cancellation token parameter. Move next async returns value task of bool instead of task of bool. And in case your project targets .NET Standard 2.0 or compatible framework like .NET 4.6.1, you may use Microsoft BCL Async Interfaces NuGet package. It's nice to know that iAsync enumerable is getting adoption. System Trading Channels library, which provides set of data structures for asynchronous interaction between producers and consumers, exposes iAsync enumerable from channel reader. Entity Framework Core allows to use asynchronous queries to avoid blocking thread while query is executed in the database. And a bunch of ASP.NET Core technologies are using iAsync enumerables for streaming capabilities. And we reached the part 2, C#8 to the rescue. Let's actually go to Visual Studio. So what we have here is a tiny Blazor WebAssembly application, which loads the list of issues for particular GitHub repo. So each issue has title, URL, author, a bunch of other properties too. And we have issues provider. So each issues provider performs GraphQL requests to GitHub, and each request returns some amount of issue objects, starting from some cursor, along with pagination information. And the first implementation, which we will consider, it uses a task of async enumerable of issue return type. So what's going on here? So here we initialize request, have a while loop, have some artificial delay for the sake of demo, and asynchronously get response. As we get the response, we append a chunk of issues to the resulting list here, report the progress to not stay completely silent. Then we check if we have any more data or if we reached some limit to not exhaust the memory, and we break the loop. Otherwise, we proceed. Yeah, we update start cursor and continue the next iteration. Now let's take a look at the consumer side. So consumer side is a browser page. Here's some markup as header, couple of buttons to start and stop loading. We display issues count and fill the table with issues data. What's interesting to look at is our start loading handler. So we reset issues, initialize some progress, which involves delegate each time the progress is reported. And then we create fresh cancellation token source and actually asynchronously retrieve the data and notify about state changes. Let's actually try and run this code. Okay, the project is building. Okay. Yeah, so usually the first load takes longer time. Our application should be opened. Yeah, happy that we see that it loads. Okay, so let's click the load button, and we see that issues counter starts growing, and then we see the list of issues, and it's all clickable and working. Okay, but this approach has obvious downside. We have to wait until all issues are loaded before we can show any of them. And because of that, we also have the artificial limit to not exhaust memory. So let's try to alleviate these problems and try another approach. This time we will try using IEnumerable of task of issue return type. Here we support the list of current page issues, and we keep track of the index inside of the current page. Then we have a infinite loop inside on each iteration we yield return the result of local function. Yes, and our local function is actually asynchronous, and it returns task of nullable issue. So at first here we check if we need to perform the new request. Yeah, if we didn't have any requests at all, or we exhausted the current page. So we asynchronously get the results, update the current page, and return item of current page and increment the index. But what's also important here, that if returned page is empty, we have no choice but to return the null value. So null value becomes the end marker of the sequence. Okay, now let's take a look at the consumer side. So what we have here is a for each loop, and each item represents the task. So we have to wait it, and in case it returns null, we break the loop. Otherwise, we add issue to the resultant list and update the page. So this approach has some improvements compared to previous one. So at least we can, show results as we download them. But it has downsides too. For instance, our producer function implicitly sets the requirements on consumer to await on each iteration. If we will ask for another item before awaiting the current one, we get invalid. We end up in invalid state. So this is not ideal. And let's try another approach actually. And another approach will use iObservable. So iObservable, as we discussed earlier, yes, is a push-based model. So here we use this factory method, observable.create, which takes asynchronous lambda with two parameters, iObserver and cancellation token. And it's actually quite self-explaining. What we have here is a loop with asynchronous request, and as we iterate results of current response, we invoke this onNext method on iObserver. And if we reached the end of sequence, we just call onCompleted. So beautiful and precise. Let's open consumer code. And this code also looks very precise and clear. So we get the iObservable, we subscribe to results, and on each result we add issue to list of issues and update state. So this is a very cool approach. iObservable is a advanced technology, but we need to remember that this is a push-based API, and this means that we have to react at the speed of producer. Otherwise, we will get stuck, and iObservable will not be as useful as it could be. Some implementations like reactive streams actually have a side channel to communicate the back pressure, or in other words, tell the producer to slow down. And all the discussed approaches, they were available before C#8, and well, they are still available, but C#8 allows us to use another approach. So this is another implementation that makes use of async iterators. So C#8 allows to combine, to use both await and yield returns inside one method, and such method is called async iterator. Async iterators, they have this async modifier, and they have either async enumerable or async iterator return type. I think this code is also very simple. We just await where we want to await, and we yield return where we want to yield return. Now consumer code. So here we use another feature of C#8, which allows us to consume async streams using asynchronous for each, which writes like regular for each, but there is a await keyword at the start of this statement. So it looks just like synchronous for each, but all the asynchronicity is hidden behind this little keyword, which is, super cool. Let's actually run the example and take a look that it actually works. So okay, application is loading. Select base implementation. Yeah, and we get the results as soon as we retrieve them. Awesome. So to conclude, C#8 provides language support to easily and efficiently produce and consume async enumerables. But C# is not a pioneer here. Dart, Python, JavaScript, F#, C++, and Kotlin, all these languages have similar feature and for a while already. So C# is keeping up, sort of. And we reached the third part, lowering the art of deception. So almost 20 years ago, famous Kevin Mitnick wrote the book, The Art of Deception, that covered social engineering. But today we're gonna talk about compiler engineering. So lowering is a technique actively used by C# compiler, well, other compilers too, which consists of rewriting high-level C# features into low-level C# features. Apparently, both async iterators and await for each that we talked about previously are in some sense a big piece of deception because compiler completely rewrites them. And I think it's quite interesting to take a look at what's going on behind the scenes. Let's actually start with a regular for each statement. So probably many of you know that compiler rewrites it into code like this. So we get an enumerator, inside try block we loop while move next returns true, and access current item through current property. And in final block we call dispose on enumerator. Pretty straightforward. Now let's take a look at asynchronous for each. And actually it's lowered just like regular for each, but methods and here have async somewhere in their name, and there are awaits of move next async and dispose async. And just like regular for each, asynchronous for each can work with any collection type as long as it has suitable shape. What are the shape requirements here? Well, collection type should have getAsync enumerator method, which actually may have a single optional or params parameter. Move next async should return awaitable type, and awaitability is also a type pattern. So you can see that type patterns are used in C# all over the place. And dispose async method is completely optional. No method, no call. But if there is a method, then return type should be awaitable as well. Now let's consider the following example. We have a struct implementing async enumerable of int interface. C# allows to omit default value of parameters when implementing interface members. And we have this little print method, which iterates over this. What's going on here? So compiler checks whether getAsyncEnumerator method is suitable. Does it have single optional or params parameter? Well, no, it has required single parameter, not optional. So it means that we need to convert this into async-enumerable interface instance, which means that we have boxing. How to avoid boxing? Just add default parameter value, and that's it. And this example actually shows how understanding of lowering can save you from unwanted performance penalties. Now, let's switch to another demo. Okay. So yeah, async enumerable has a couple of useful extension methods defined on it, with cancellation and configure await, and both of them return the same type. Let's take a look at the definition. So yes, and we see that configured cancelable async enumerable doesn't implement async enumerable interface. However, it has suitable shape, and therefore it can be enumerated with await for each. Here we see that it has get async enumerator, which calls get async enumerator on original enumerable, but passes cancellation token there. And we have this return type enumerator, which is also read-only struct, and it has all this move next async, current, and dispose async. So even framework makes use of this type pattern. In our example, we explicitly pass cancellation token into async iterator. However, in some cases, all what we have on input is async enumerable, and we have no knowledge if it's cancelable in any way. So in such cases, with cancellation is extremely useful. But let's actually provide a second cancellation token and see if it works. So I will duplicate cancellation token source here. I will also copy paste this code, and let's update it here, and we name it CT2, so cancellation token 2, pass it here. Then we will copy this handler as well, name it cancel loading 2. Yeah, and we actually need one more button here, which we will trigger this handler. Okay, let's run the code. Yeah, so our project is building. Okay, it's loading. Yes, click load. Yeah, click cancel to, and it doesn't work. What's the actual heck? Cancel works. Okay, let's take a look. What's the problem here? So if we will go to definition of our async iterator method, we can see that cancellation token is marked with compiler warning. Async iterator has one or more parameters of type cancellation token, but none of them is decorated with enumerator cancellation attribute. So the cancellation token parameter from the generated blah 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 will be unconsumed. So here is the solution to our problem. I think we will not run the sample again just for saving some time, but believe me, it works now. Okay, now let's discuss lowering of async iterators. Just like in case of regular iterators and async methods, C# compiler generates the beautiful thing called state machine. As practically all compiler generated entities, it has unpronounceable name, which is why I called it here Voldemort state machine. So what is a state machine actually? So state machine is a model of computation described by the set of states and transitions between states. And let's take a look at the states and transitions of async iterator. So state machine is created in finished state, and get async enumerator moves it into initial state. When consumer asks for first element, we move to running state. And at this point, we actually start executing the code. At some point, we may hit a wait of async operation, which suspends the execution and move us to suspended state. Later, this async operation resumes and state machine re-enters the running state. When we hit yield return, we finally reach the yield state, and we stay in this state until consumer asks for the next element. Then state machine is spinning around this running suspended yield states, but finally it reaches the finished state either by completing normally or with exception. Now let's take a look at the class generated class again. So it implements a bunch of interfaces. Of course, it implements async enumerable as that's what we have as our return type, but it also implements async enumerator. It allows us not only not to generate the second class, but also it allows us to return this from getAsync enumerator, but only if getAsync enumerator is called on the same thread that state machine was created. Also, we have a couple of these interesting interfaces: I-value task source of bool and I-value task source, non-generic one. Why do we need these? So as we showed earlier, state machine implements async enumerator interface and must provide two async methods: move next async and dispose async, which return value task of bool and non-generic value task. Using value tasks as return type allows to avoid task of T object allocation if method completes synchronously. But can we reduce allocations on asynchronous completion path as well? It turns out if usage pattern doesn't allow to run multiple asynchronous operations concurrently, then we can reuse single object representing completion of async operation. And that's exactly the case with async iterators. So we request items one by one. We never run multiple move next async operations concurrently. Instead, we invoke move next async, wait for its completion, and only then request the next item. To support this pattern, value task has got a constructor taking iValue task source. And implementation of move next async and dispose async can pass this reference there. You can imagine that implementation of iValue task source interface can be non-trivial, and it is. However, base class library provides the standard implementation as a manual reset value task source core type. And generated state machine just delegates everything into a field of this type. Now let's take a look at the decompiled code. I think I need to tweak one option. Yes, I need to uncheck use sources from symbols. So we didn't, so we actually could decompile and not use our program sources. So here we have our issues provider. Let's open our implementation. So we see that this method is marked with async iterator state machine attribute. And as we remember, it has cancellation token parameter. Here we create state machine object and we store parameters, including cancellation token, into its field and return it. So let's take a look at the generated state machine. So as we discussed, it is a compiler generated class implementing a bunch of interfaces. It has this manual reset value task source core field along with lots of other fields. And it has this giant method move next, the core logic of state machine with lots of go-to statements. So arguably go-to statement is considered useful if it's generated. But what is interesting is a get async enumerator method. Yeah, I actually forgot to compile the code after I added enumerator cancellation attribute. Oh, let's do this. Okay. Let's update the code. And scroll down to get async enumerator. So remember that we have cancellation token original one stored in the field. And we also have additional cancellation token coming to get async enumerator. And this code actually, so what it does, it checks if both cancellation tokens are not equal and are have non-default value, then we combine them with cancellation token source, create linked token source method. So that's how it actually works. If you want to actually see how lowering of async iterators is implemented in the compiler, I invite you to download the Roslyn source codes or visit sourceroslyn.io and look at the async iterator rewriter class. It's quite readable and has lots of comments. And we reached the final part, the art of async querying. We all love LINQ, and ReSharper is known for its ability to rewrite these nasty, imperative for each loops into beautiful sequences of standard LINQ operators, making the code declarative and super clear. But the LINQ we all know is defined on IEnumerable and can be used with IAsync enumerables. And although .NET Standard 2.1 includes IAsync enumerable, unfortunately, it doesn't provide all those extension methods that are required for a LINQ to work. So do we need to sit down and implement them ourselves? Fortunately, no. There is an existing NuGet package, system LINQ async. With all extension methods in place, we can easily use query comprehension syntax, which is another C# feature based on type pattern, actually. But what we still can do is we can't use a weight expression in there. But who knows, maybe we will get it in 5 years or so. Let's get back to our demo. So let me uncomment this line to include this package reference. Okay, what I'm gonna do is I will try writing some request, some query actually, yes. So let's try to get nullable reference types issues. What we're gonna do, we will we'll invoke our method, pass owner name, repo name there, and yeah, we actually need to invoke double completion here, so that postfix for each postfix template item is available here, and when we complete it, async modifier is added. Now let's check if issue categorize equals to nullable reference types. And if this is the case, we will return issue. And now we need to fix the return type. Yeah, okay. So you can notice that there is a little squiggle thing there. It says loop can be converted into a LINQ expression. So let's try. Oh my. So yeah, we're using asynchronous LINQ there. Now let's try to convert LINQ to code again. Yeah, and it works too. Yeah. So I actually implemented this feature around 1 week ago. So it will be available in the upcoming version of ReSharper and Rider. But now I would like to do something else. Let's extract this expression into separate method and call it predicate. And what we're gonna do is we will use some asynchronous operation here, like task delay. Let's fix the return type here, and let's await this call. And you know, we still have this squiggle. So let's try. Oh, that's something new. So we have not just simple where, we have where await. Yeah, and this where await method, it actually takes a predicate that returns task. Yeah, so async link is not just like ordinary regular link. It has some additional operations which take asynchronicity into account. Actually, there is one more family of functions that end with await with cancellation suffix. Yeah, and we can pass. Yeah, there is an additional parameter here, cancellation token. Yeah, all right. Okay. But as we talk about querying, what about iQueryable? So iQueryable is super cool because it allows to offload some computations somewhere remotely. And it is allowed because in C# Lambda expressions are convertible not only to delegate types, but also to expression trees. Let's take a look at the prism we have seen before and think, what's the place for iQueryable here? I actually thought about this and came up with another dimension. So I call this dimension code as data. It's quite obvious that iQueryable corresponds to IEnumerable, but if there is a correspondence for this one, there should be something for other types as well. Well, let's actually fill the gaps, and we will have the following types. So for singular result, we will have iQueryable scalar type. For observable, we'll have iQueryable observable or simply observable, and there are types that take asynchronicity latency into account. And apparently, some of these types do exist as part of .NET Reactive repo. So reactive extensions, RX Rocks, and other two types, queryable scalar and async queryable scalar, we can actually implement them using the take one operation. So summary, there is a diversity of async streams. .NET Standard 2.1 introduced standard API for pool-based async streams. C# is keeping up with other modern languages, and ReSharper and Rider are always here to support you. I think we're reaching time limit, and I should stop here. Okay.
All right, great session, Andrew. Thank you. I have a couple of questions from the audience, and let's maybe start with the one that was asked most in the past couple of minutes or the past hour. And that is, can people find your samples somewhere online?
Yeah, so I will post them. So currently they are in private GitHub repo, and I will make it public.
All right, cool. So they just search your name on GitHub, I guess.
Yeah, I actually had it somewhere in the beginning. Whoa. Yeah. So I go with a curve of 89 handle everywhere.
All right, perfect. Then let's go for the heavier questions. One is, what are your recommendations regarding converting a push-based stream into pull-based? Are channels the most efficient way to do that, or?
So yeah, probably channels are efficient way, but you should know what you are doing, because you should select one of these collections based on your requirements. If you do need to convert push API into pull, there certainly can be some work to do, because pulling can be slower than pushing, and you need to put some buffers in place, and you can create channels with such buffers. Yeah.
Right, cool. Follow-up question on that one is, how would you go about merging two pull-based streams? So for example, if you have two stream readers and you want to read them line by line from both simultaneously, how would you yield the lines that come in from those two?
Okay, yeah, great question. Well, actually, you can take a look at the zip operation that is defined in async system link async, and take a look at its implementation. So zip operation takes two async enumerables and produces the result.
All right, cool. Yeah, there's another question on what are the best use cases to use all of these interfaces. When should you avoid using them?
Well, so I showed you the diversity of types and recommendation. Look at your requirements. Look if you need to take latency into account, and take a look at the kind of data you are working with. If it's inherently pool-based data source, use pool, and if it represents some sort of stream of events, then use push. And yeah, I had this prism. Yeah, so you can select the collection type based on pool, push, and latency axes.
All right, cool. Then maybe one more to end the session with, and that is how do you catch exceptions in the iterator? So for example, the place where you do the yield return, can you just put a try catch around that, or is there a better way?
Yeah, so async iterators work just like regular iterators in this sense. So if you get an exception, you can easily catch it with try catch block. You don't need to advise some new smart mechanisms about it. Yeah, you just catching an exception, and that's what I have here in my code. So I have this wait for each loop, and it is in try catch block where I catch operation cancelled exception. Yeah, simple as.
I think the question was more about your get issue async method there. If in that one there's an exception, how do you catch the exception internally in that method?
Yeah, so just use try catch, yeah, and it works.
So it should work around line 167, right?
Yeah, sure.
All right, perfect. Thanks. A couple of other questions coming in. Let's maybe end with one, and also one compliment, which is that the prism that you drew on slides is amazing, and people are probably going to reuse that one. One question that is left, and that is, why should you prefer the async enumerables over RX framework?
Well, you shouldn't just blindly prefer it. You just weigh your requirements. That's what I say everywhere. People ask me about that. So if you if you are working with a pool-based API, use async enumerable. If you work with a stream of events, use iObservable.
All right, cool. That makes sense. There's a couple of other questions that we'll handle via text. But other than that, I guess we can wrap up here. Thank you again for a very interesting session. Thanks everyone for joining us. And yeah, let's quickly switch back to my screen here.
Thank you.
Yep. Thanks again. Thanks everyone for joining. And we will be back in close to half an hour with Tess Fernandez, who is transitioning from C# to Python and sharing all of the things that she learned along the way. So stay tuned and we'll see you in half an hour. Hey, everyone who is still watching. Don't mind our quick tech check that we're going to do. So what we're going to do is quickly switch screen to the next presenter screen, Tess, see if that works, and then we'll be back anyway in about 15 minutes.
I think I am sharing. Oh,
Yeah, you are sharing. It's a very wide screen though.
okay, it's sharing the wrong screen. Let's see. Okay, is this better?
Yeah, that's PowerPoint, I think.
Okay, perfect.
All right, perfect.
Yeah.
Thanks. We can switch back. All right, let's do this. Hey everyone, I'm Martin from JetBrains, and welcome again to the JetBrains.net Days Online. With us, we have Tess here, who will be
Hello.
hey Tess, who will be talking about C# to Python and all of the things that she learned along the way. And I always say to everyone that I meet that looking over the hedge across the ecosystem boundaries and looking at other languages is super important. So I'm very, very curious to see what you'll be talking about.
Cool. Well, thank you so much for
I'll,
having me.
Thank you for stepping up. I'll let you introduce the rest of the session, but before we go there, I quickly want to cover a couple of practical things. First of all, if you have any questions during the webinar, feel free to ask them in the GoToWebinar questions pane. I cannot promise that we will be able to answer every single question that comes in because there's a lot of people online. We will try to ask a couple of questions to Tess, and yeah, whenever there's something that you're thinking of, feel free to post it there and we'll see what we can do with it. Also find Tess on Twitter or on the contact details that she will no doubt share on the slides as well if you have any follow-up questions. This session and also the next sessions in the JetBrains.net Days Online will be recorded. So if for some reason you have to drop off or you want to check a session that you could not attend, feel free to check our JetBrains TV channel on YouTube in the coming days. But of course, we would like it if you stick around for the sessions while we present them. With that, let's switch over to Tess and look at some C# to Python.
Yeah. So let's just make sure I'm sharing the right screen here. Cool. Are you seeing my presentation, Martin?
Yep, looks good.
Okay, cool. So I'm actually going to drop off the video feed. But as Martin said, you can feel free to contact me anytime. I did forget to, to add my Twitter handle, but it's Tessfriend is this one word. So please do contact me whenever you want. I am Tess, and I'm a software engineer and data scientist at Microsoft. And for about the past, I would say around 20 years, I've been working in C#. And then around 4 years ago, I started doing data science, machine learning, and all that good stuff. So I was sort of forced into this world of Python. And what I'm going to talk about today is my journey basically to production systems in Python and a couple of things I learned along the way. So hopefully, no matter where you are in your journey, whether you're just beginning or whether you've been doing this for a long while, I'm hoping to give you at least some tips and tricks. And I am quite opinionated, so in some cases I will say, I think you should do this. It doesn't necessarily mean that you should, but at least hopefully this will give you some input for what you could do. So my first part of my journey was to set up a really good dev environment. And this actually took me quite some time to get it right. In the beginning, I was working in notebooks, which I'll talk about later as a no, we're not doing that. But what I was also doing was I started working a lot in VS Code. So right now, actually, I'm using two main development environments. I'm using PyCharm from JetBrains and VS Code from Microsoft. So you can kind of compare these for C#, like how and these two Visual Studio versus Visual Studio Code for C#, where PyCharm is this bigger, full-blown IDE with all with everything you need, including like test runners, built-in code style validation and things like that. But it's a little bit on the heavier side versus VS Code, which is very modular, and you can install it on machines where like very quickly. However, you do need to install a lot of extensions. So right now, my current mode is that I use PyCharm most of the time, and I use VS Code specifically when I want to connect to a remote data science virtual machine or something like that. If you do want to work in PyCharm, I think you can download it for free. Martin can probably answer that in the chat if that's not correct. But it's a really great environment that takes care of a lot of like making sure you have everything set up. Visual Studio Code, on the other hand, like I mentioned, needs a little bit of caretaking to get it to where you want to be. So these are some really good extensions that I recommend for Visual Studio Code. The Python language extension, which helps us set up everything code related to Python. So for example, configuring your test runner, selecting your linter, which I'm going to talk a bit about what I'm using as far as linters and things like that. And also in the third section here, you see selecting your interpreter. So that's your python.exe, depending on if you want to use Python 2 or Python 3, and also if you want to use virtual environments, which I'll talk about. Then in Python, if you set up the Python extension, if you set up a linter like Flake 8, you also get sort of like information about what you should change to make sure your code follow the PEP8 code style. And this is something that actually PyCharm is doing by default, so you don't have to install anything. It automatically sort of gives you validation as far as how your code should look. So if we look at PyCharm, it would look like this, and automatically it would then tell us information about things that we're doing wrong in our code and should change. The next extension that I really like is one that's called PyWrite. PyWrite is an extension that helps us with type hinting. So Python in itself doesn't have strong typing, but you can include type hinting, as you see here, so telling the interpreter what your parameters are, what types they are, and things like that. But we'll get into a lot more of that later. This extension, trailing spaces, is a really good one if you work with something like Flake 8 as a linter. So this gives you information about like where you've actually put in some spaces that you shouldn't have in there. So this is just a good helper extension. And then finally, a good extension if you're working in VS Code is the remote development extension, which helps you connect remotely to a DSVM or a dev container, and then a good test explorer. But as I mentioned, if you work in PyCharm, pretty much all of these things come from the get-go without even having to configure PyCharm all that much. So I tend to use PyCharm about 90% of the cases, and then some odd cases I'll go back to VS Code. So once you have a good development environment set up, the next part is writing readable and maintainable code. And as opposed to, for example, C# where we already have the paradigm chosen for us, we're going to go object-oriented whether we like it or not. Python is a little bit different in that you can choose and pick and mix whatever paradigms you want. So as an example, when you start out, you'll quite often use the imperative style. So this is what you'll use in notebooks, like they're more recipe style. Read the data, print the first 5 records, plot a price, and do one thing after the next. Whereas, sorry, not whereas, but if we do this, we end up in a situation where we repeat a lot of the code. We can't test code that's written in this style. So a good evolvement of this is using procedural, the procedural paradigm. So what this does is it encapsulates our code then in functions and modules and things like that. So basically saying that we shouldn't leave anything as raw. Instead, everything should be either a part of a function that's reusable or a part of a module that's reusable. And this also makes sure that we don't use global variables and things like that in Python. And this is quite important when it comes to Python, because if we use global variables and we just misspell them a little bit, since it's not a compiled language, we might be using a completely new variable, and we might introduce bugs that are very, very hard to track down. So at least going procedural is a good choice. if we want to take this one step further, we can also do functional programming in Python, which in Python actually we can't do proper functional programming or pure functions, but at least it allows us to do things like use functional paradigms like reduce, map, filter, and things like that. And then finally, we can also use object-oriented programming. So if we do want to come in from a C# angle, we can definitely also create object-oriented applications. However, it doesn't allow for encapsulation and things like that. But the good thing about this is that we can very much mix and match these. And in terms of data science, using functional programming is a very good thing because it allows you to iterate over large sets of data, whereas object-oriented programming doesn't really lend itself so well to do data science. But all in all, my suggestion for all of these is you mix and match as you want, but do follow like the regular code conventions, like splitting codes into modules and functions, avoiding global variables, and also, as I mentioned a couple of times now, follow some type of code standard. And the basic code standard for Python is PEP8, and also use type hints. If you want to know a little bit more about PEP8, there's a pep8.org which talks about all the different rules, and you can then choose which ones you should or should not follow. As an example of how this looks, this is a piece of code that it's kind of hard to read on first sight, even though it's just a few lines, but this multiplies two random numbers. But if we go in and we apply a linter to this, and the linter in this case is Flake8, which lints according to the PEP8 standards, it tells us a little bit about what we should be changing, and we can clean this up quite a bit. So we can go in and for example, clean up the unused imports that it complained about, add some separating lines that it complained about, fix white spaces, remove unused variables, and then it will also complain about things like myfunc, which is not a word, and therefore is not a good function name either. So it will then ask us to do something else, and suddenly we have a lot more readable code just by applying the PEP8 standard. And the other thing we can do is, as I mentioned before, also apply type hints. So type hints, the way that works is this. We have a function add, adding a plus b. This can be called with any type of variables, actually. So with ints or strings or lists, and it will never complain. It will just do whatever plus means for that data type. This is quite useful, but also quite annoying, mostly for the caller, because the caller doesn't know what was intended as the input and output, but also because it introduces some quite weird errors if we use it wrong. So for this purpose, from Python 3, you can add type hints. So type hints then allows you to tell the interpreter or PyCharm or PyWrite extension that we're actually expecting an int, and you should warn me if it's not an int. And in that case, PyCharm will then warn us by turning our parameters yellow and saying this, you can go through and do this, but this is not what we intended. So type hints is a really good way to remove some of the pesky bugs in our code. Now, once we have good and structured code, it's time to test our code. So the third learning is around really using PyTest, which is one of the more used test frameworks in Python, to your advantage and use it to its full meaning, so to speak. There's really PyTest and unit test, and PyTest is a superset of a unit test. So right now, most applications that you meet will probably use PyTest as a tester. So as per all code, not just Python code, you should follow like a regular test test design guidelines. So starting each feature or function by really thinking through what it is that it's supposed to accomplish and what you should test, naming your tests appropriately, writing only the code needed to pass the test so you have proper code coverage, etc., etc. All of those obviously apply here, but specifically for PyTest, a couple of things that that are interesting is how you can use it. So the first thing, we're going to test this function add. To test it either with PyTest or unit test, you would write a simple test case like this. And what's different from other test frameworks is that you have to either start the function with a test underscore or end the function with an underscore test. But otherwise, you just act, arrange, assert as normal. Now, if you have something a little bit more complicated, like this function right here, where you're trying to tell, like you have a function that removes a file if the file exists, you might not actually want to test the OS path or OS remote. These are system libraries that are well tested, and there's no need to test them in your remove file. In that case, you want to do something like mocking, but because Python doesn't have interfaces and things like that, you can't really go through and create another version of this class that only implements your version of this file. So instead we go through and we do something that's called patching or mock patching. So we say we want to patch OS path and we want to patch OS. And in this case, we want to create a test function that just verifies that we don't remove the file if it doesn't exist. So the first thing we say is we want isFile to always return false. So isFile shouldn't exist, this file doesn't exist. And then we go through and act actually call this function, but every time it's going to call isFile, it will just simply return false. Not go in and actually do OS path isFile. And then the third thing we want to do is we want to assert that we didn't in fact call OS remove. So that is as simple as just do mock OS remove called equals false. So mocking is a very useful thing, is to not have to call into functions you don't own or functions that are not part of this particular unit that you're unit testing. Some other things that are good in PyTest are fixtures. And fixtures are meant for you to supply, for example, sample data that you want to supply the same sample data to many different functions. So in this case, I want to test that clean features does something, and I want to test that extract features does something, but I don't want to have to rewrite this whole sample data over and over and over again. So then I just pass in house features as a fixture. So this is similar to a setup or something like that in C#. Something else that's also quite useful, and this is similar to a test case in C#, is parameter size. So if you want to test the add function, then you want to test it with a number of different values. So maybe small values. I want to test it 1 + 2 is 3, and negative values that -1 plus minus, or -2 plus -1 is -3. Then I can use this parameter size, and then I can pass, sort of like call this same test add with a lot of different parameters. Finally, sometimes you have functions that take a long time to run, and maybe integration tests and things like that that you don't want necessarily as part of your automated testing. And in that case, you can use PyTest mark to mark some of the tests. And using, in this case, I've used long running, but I could equally just call it PyTest mark test and mark some of my tests as with my name, and then say, I want to just run the ones that are marked like this, or I want to run everything but the ones that are marked like this. So that's a useful feature for differentiating your unit tests versus your integration tests or smoke tests. And then once you're done, you would, of course, run them either in the PyCharm test runner or in the test explorer. So that was sort of learning number 3, how to run, how to create really good tests in Python. The next one is around automating the boring bit. So essentially, we know that we should write it in certain code style, and we know we want to automate running our tests, etc. But how do we actually automate this stuff and build validations or locally on our machine? One thing that we could use is this library called Black. So Black is a code formatter that will format your code as PEP8 without you having to worry about it. However, it's a very uncompromising code formatter, which means that it will format it and you can't decide how it should format it. So, well, this is good for sort of like my sample demos and everything. I wouldn't necessarily use this in production. Instead, I would use something like auto PEP8, which I can configure. And then I would also automate linting using FlakeH, which I've shown a couple of times. So apart from my build validation, I tend to do this not only when I submit a PR, but also locally to avoid having to go through the whole PR cycle, fail the PR, build validation, and then have to go back again. So this is not specific to Python, but I wanted to throw this in there because I find GitHooks really, really useful for an interpreted language like Python. So what this will do is it will simply, whenever you do a git commit, it will run Black, and then it will run FlakeH, and it won't commit unless this worked. So a really good thing to try. Let's see, what was the name of the first extension presented just before Pywrite? I think that might have been the Python language extension. Sorry, I just saw that in the chat. Okay, so once we've automated what we want, let's talk a little bit about dependencies. So if you have a project that uses the pandas library, you can either do pip install pandas or conda install pandas, and that will install the latest version of pandas on your system. Now in my first project, I might have this version of pandas, and then I go into another project where they use a completely different version of pandas, maybe an older version of pandas that because they needed some specific feature for it. And then we have some other project where you use like late night pandas, and then you go back to your previous project again and you have to install that pandas again, and so on and so forth, because they're installed system wide. And suddenly you end up in a situation where things get really bad, like you become really, really sad, because all you're doing all day is uninstalling and reinstalling these libraries, and you even end up in a situation where you installed something that completely ruined your whole Python environment. And obviously that is not a good feeling. So how can we make this work sort of like the way that it works, for example, for .NET, where we have a dependencies.json, and we only install that for that particular project? The answer is something called virtual environments. So virtual environments, you can see them as folders on your system where you install a whole Python environment in a folder, and you install everything you need in that folder. But then when you're done with the project, or when you're done developing this project, you then deactivate that folder. So it goes like this: create a new virtual environment called my environment. You activate the environment, you install requirements.txt. So I'll get into what requirements.txt is in a bit, but that's sort of like similar to your dependencies.json. You work on the application, and then you deactivate the environment. And now you can now go to another project and do the same thing over there. And that way you don't have like conflicting versions on your main system. You can do this also with Conda. So Conda is another package manager that you can use, and which one you choose mainly depends on your own personal preference. I would say Conda is a little bit different as far as a package manager because it also includes some C libraries and things like that. But both of these rely on something called requirements.txt. So requirements.txt is essentially Python's way of dependency management, which you can, or at least to me, it's a little bit funny that it's a .txt file. It feels a little bit like an afterthought. But what this is a list of the libraries that you would like to install and their versions, or if you don't give a version, it will show the latest one. So you're essentially saying pip install everything that's on this list, and that will install all these libraries and all their dependencies. Now, PyCharm has a really good way to deal with these virtual environments. Every time you open up a project or create a new project in PyCharm, it will automatically ask you to create a new virtual environment. And it also has good management of requirements.txt. So in this case, you see that some of them are yellow, and that just means that they are outdated. So if we look, for example, urllib 124.2, that is definitely not the latest version of urllib 3. So, and this gives you a little hint of maybe you should be moving to a later version and testing with that. The other thing that PyCharm also does in terms of requirements.txt is this. If you haven't installed everything in requirements.txt, it will let you know so that you can install them. And this is quite useful when you're working on a project with many different developers where someone is now using a new package, they've added it to requirements.txt, and then you're now notified that you don't have everything updated on your system. But the front of this is basically to say, please use virtual environments, whether you use Conda environments or virtualenv, so you can keep your machine clean and your pandas separated and everyone is happy. My next learning is that to parse arguments with clicks. So a lot of Python applications are really script files that you run from the command line with a number of arguments. So let's say, for example, in this case, you have a function that takes an input file, or a script that takes an input file, an output file, and a debug flag. So typically, Python scripts will use argument parser. That's sort of like the default thing to use. And it's quite nice. It gives good help and all of that. But it does have a few flaws when it comes to maintainable code. One question you might ask is, how would I even test main? For example, how would I test main with different input files, with different output files, with different debug flags? How would I validate parameters? This doesn't really feel very readable because there's a lot of code inside main that just has to do with argument parsing. And the solution to all this is to use click. And this is something that I learned way too late, I have to say. But since I learned it, I just love click. So what click does is, instead of sort of doing the argument parsing inside the function, you use a decorator instead, and you can then split your script up into different commands and tell sort of like what arguments and what optional arguments you have for the script. And what this does is it does a couple of things. Mainly, it puts all the parsing outside of the function, but it also adds parameters then to the function so that now suddenly you have a testable main function that you can pass different parameters to and call explicitly. It also does a couple of other things to it. You can use custom types and thus do type validation. And it's a lot more readable because your main function doesn't have a lot of argument parsing anymore. So if you learn nothing else, and if you haven't used click, I would say this is like the #1 tip. The next step is around embracing Pythonic Python. And I think this is true for any language that you work with, whether it's Python or C#, that you should spend some time looking at really good native code and what good developers are writing in the native language so that you can use, in this case, the Python way of doing things, both because they allocate memory better, because they're faster usually, but also because they become a lot more readable if you do things the Python way. So some examples of this. Let's say we want to square some numbers. So we have a list of numbers that we want to square. And the C# way of doing this would look something like this, like a while loop through all the numbers and appending like number times number. But this has some issues in here that we have to sort of iterate over this, or we have to increment this variable I. That's actually not even needed, but we have to do that in order to pass on to the next value. So a better way to do this would be to use a for loop, and then we wouldn't have to worry about maybe running into like an infinite loop or something like that. However, this is using the for loop in a very C#y way, thinking that the for loop in Python is actually a for loop in C#. But it turns out that in Python, the for loop is more related to the for each loop in LINQ. So a more Python way, or a more Pythonic way of doing this is to say for num and nums, just append num times num. And then we've sort of like removed the indexing, and we've also used it as it should be. But an even more Pythonic way to do this is by using list. Sorry, it didn't slip my mind what it's called, list comprehension. And this is a way to write a for loop inside the list itself, just to get it as a one-liner. So this would create a list of num times num for all num in nums. This also allows things like filtering. So now it will just create a list of the squares of the numbers that are even and not the odd numbers. And we can get crazy with this. We can have like nested for loops and things like that. And we shouldn't really go that far. In that case, we should definitely go for a for loop instead. But if you just have a simple case, this becomes much more readable and much quicker to read if you don't have to sort of like flood your code with unnecessarily loops and things. Another example, let's say we want to sum all the numbers between 10 and 1,000. So this again is a typical way to do this, maybe C# style, but then using the built-in functions in Python, we can instead write this a lot simpler. Like total sum is the sum of all numbers in the range from 10 to 1,000. And finally, another example is this item in the list. So Python does a lot of list processing. So finding an item in a list is a very, very common thing in Python. And this would be a totally valid way to do this, but a more Pythonic way to do this would just be to write found equals sherry and fruit, or if sherry and fruits. So spend some time and look at a lot of Python code and spend some time on sort of figuring out what the Pythonic constructs are. And there aren't too many, so it doesn't take a whole lot of time to actually go through and get better at writing Pythonic code. Now, the next tip is on how to keep your secret in Python. And one good way that I found and that I use quite a bit is with environment variables, and specifically with .env files. So this is an example of an environment variable file that you can just have in your project. And what will happen if we go through and load it up with .env is that it will mix and match whatever is in the .env file and also in my environment variables, in my system environment variables. So this is quite a useful way to, for example, save my secrets, but also to have different configurations in different environments, like in production or dev. For number 9, I've saved the notebooks to be or not to be. And I started out doing a lot of notebook work. And in fact, like the first year of working with data science was mainly in notebooks. If you're not familiar with notebooks, this is how they look. So in notebooks, you can mix and match code in code cells along with things like Markdown or LaTeX. And the cool thing about this is, of course, that you get sort of like you build a story and you can get a lot of diagrams. It's a very good way of browsing through large amounts of data and representing them nicely and sort of creating like a story around your data. And if you haven't seen this before, and if you come from the C# world, then there's also the same thing actually available in C# now. So you can use notebooks in both C# and F#. So for a long time, I thought this was the way to work with data science in Python until I had to put something in production. And I realized that working in notebooks it's not really that production friendly, to be honest. First off, the code structure is very difficult to get a good code structure. It's very difficult to get good code reuse and things like that. For example, putting reusable code in functions and including them in notebooks. You can also run cells out of order. So I could, for example, run cell 1, cell 3, and cell 4 and end up in a situation where like someone looking at the notebook after me had no clue how to reproduce what I saw in the notebook. The other problem with notebooks is that when you put them in source control, they contain both the code and also the information about what the run, like how the run went, so the output of the run. So that means that if you run it and then you run a few cells out of order and then you git again, you'll have a different git than the previous person that ran it. So it becomes a little bit hard when a source control diff isn't really a code diff, but actually a run diff. So that is not a very nice thing. The other thing is debugging code. And I know that there is some tries now with debuggers for notebooks and things like that, but that's still very kludgy compared to debugging code in a Py file. And testing code. Again, some people are trying it out, but it's sort of like an after the fact thing, and it's very difficult to test code in notebooks and to lint code in notebooks, or to even set up like a CI/CD pipeline. So my suggestion, if you're working with notebooks, is to work with notebooks while you're exploring and experimenting, but then keep them as a private thing, used for experimentation and exploration. But if it's going into production, it needs to go in a Py file. And if you made a good report, instead of just leaving it as a notebook, then save the output as HTML and PDF, because if someone else runs the notebook, they will have a completely different view of what happens. And some people might say, well, I'm using notebooks because I want to have an interactive environment where I experiment. But it turns out that both PyCharm and VS Code can run interactive sessions inside PyCharm and VS Code themselves. So by just adding these hash mark %%, you can create your own cells in .py files that you can run one by one. So when seeing the output. And actually in PyCharm, there's also a very good way to look at data sets and things like that if you have the pay version. Finally, it's number 10, putting it all together. And I will suggest using a cookie cutter project structure if you don't have your project structured in any other ways, because a lot of Python projects end up a little bit like this, like a big pile of files. Like you have clean dataset.py and then a clean dataset2 because you changed something a little bit, and maybe you version it because, I don't know, it was different this day, or maybe I give it like my initials and -1, and then I created like a super final version of this cleaning script because this is my way to do versioning now. I don't trust Git anymore. I don't know, but this is like what you'll see a lot when you're coming into someone's data science project. And instead of doing this, I will suggest to start off every data science project or other projects well from the beginning and not let it get to this point. And for that purpose, the cookie cutter data science project is a very, very nice starting point. So the cookie cutter data science projects, I'm sure you've heard of cookie cutter before, maybe in other constellations. So cookie cutter is just a way to create a template for a project. And you can create templates for C# or for Python or Go or whatever you want. This particular cookie cutter data science template is how you create like a good starting structure for projects that have to do with data science in Python. And it's very, very opinionated. It's opinionated about how you should store your data. It's opinionated about how you should use your notebooks and how you should keep your secrets and all of that. But it also gives a good starting point, so you don't have to remember all of these last 9 tips because you get them for free just by using the cookie cutter data science project. So it looks like this in the structure. So it structures your data as far as your raw data and your process data. It structures your code in a very nice way. It structures your documents. It talks about like how you should actually name and structure your notebooks and where you should store your reports, etc. It already has things like the requirements.txt built in, so you don't have to worry that you forgot about that. It worries about how you should store your secrets. And it even has in the setup of your virtual environment. So you have that taken care of, and also so you can have parts of the projects be packages that you can reuse in other projects. It fixes things like it uses Click, it uses Flake8, it uses PyTest. It does use a few things that I don't use on a daily, like Tox and Sphinx for documentation. And then I specifically added 2 things to this that I like, both a pre-commit, but also a test folder where I add all my tests outside of the source folder because I don't think that tests belong in the source folder. So those are essentially the only 2 additions that I make to this, and this is a project structure that I start most of my projects with. And finally, one thing I don't like about it is that it doesn't have a choice for AWS or Azure or Google. It picks AWS by default, but you can definitely use it whether or not you're using AWS. You can just ignore the initial settings for your AWS setup and instead add the Azure or Google equivalents. So to use this, you just pip install cookie cutter, and then every new project you want to start, you just do cookie cutter and then use this template. And I want to say use a cookie cutter project structure because other people will thank you. This is sort of like their slogan. but I will come and thank you personally if you use a cookie cutter project structure, because it makes such a big difference coming into a project where the structure was set from the get-go, or the repo structure was thought through, versus using one where it wasn't. Now, those were my 10 sort of like big learnings. I hope you learned something from them. I do have an extra bonus, which is a little bit a reason why Python is actually such a good language for machine learning and data science, because there's always a package for everything. And I think as a Python developer is a good learning that there is usually a package for everything, and that you don't necessarily have to rebuild or reinvent the wheel. But I also want to put in a word of caution that if you use a package that's out there, just make sure also that, just like if you would use a NuGet package, that it has enough downloads, that it has an open source repo. So in the case where you add this to your Python or sort of to your production project, and somehow that project gets lost or whatnot, that you at least have the option to, fix bugs or rebuild it if you need to, so you're not stuck. So it has libraries for plotting. This is plotting with Seaborn. It has libraries for creating neural networks, which is one of the few languages where you can actually easily create neural networks out of the get-go. So if you've never seen a neural network in code before, this is pretty much the only code you need to create a neural network. This is Keras. A few more lines to compile it and things, but this is how uncomplicated the code looks for writing a neural network. What's really complicated about training a neural network is actually the data that goes into it. So it's not necessarily the code, but much more the data and thinking about that. It has libraries for pose detection, or in this case, this is actually a little interesting library called optical flow. So optical flow, specifically if you're working with images or video, what it does is it takes like a pixel and it follows it through the video. So let me actually run this. This is something that's included in the OpenCV library. So what this does is it follows a few different pixels in the video, and what you get out of this is vectors and things about how these things move. So if you want to create anything that's based on how items move in a video, like for example, a machine learning model based on this, this is a package that already exists and you don't have to rewrite such a package. Or something like, you're just doing simple object detection, you don't need to retrain a model yourself. There's already pre-trained models that you can use, and this is the amount of code that you have to write to figure out that there's a person in this picture and there's a ball in this picture. Or something like background removal. So this is also something from machine learning project that I was working on, where I'm going to run this into just a second. So what this does is it creates a mask for the background so we can focus only on the people in the picture. And this is not a machine learning library, but a simple sort of like what pixels have changed since the last frame. So it works well for steady cams, but it doesn't work well, as you saw, when the picture is panning like that. But all of these libraries are already there, and you don't have to sort of like reinvent the wheel and implement these algorithms, which is quite useful. And this is also the reason why we do machine learning in Python and not in C# or something else usually. So that was a summary of my learnings over the last 4 years of Python. So setting up a good environment, creating or writing good structured code, testing, automating everything, setting up virtual environments, using Click for parsing, writing Pythonic Python, storing your secrets, and to use or not to use notebooks, and finally structuring your projects. So with that, I just want to say thank you so much for listening, and I'm not sure if there were any questions.
There are quite a few, so yeah, we can do that. Thanks. First of all, thank you for a very interesting session. I've actually never looked into Python in too much detail, so I learned quite a few things there.
Okay.
So yeah, let's now maybe go over a couple of the questions that are there. One of the questions, actually a couple of them, were around extensions and packages. So let's maybe get those out of the way first, if you can quickly go do them. One is what the first extension that you presented was just before Pyrite.
Yeah, and let me see if I can actually move back to, I know I'm showing my background right now, but let's see if I can do this. Okay, so I think these are the extensions that I use. So the first one is actually called Python. It's a Python language extension. So for Visual Studio Code, you essentially have a language extension for each language that you use.
All right, cool. Yeah, another was around the library that you used, or the module that you used to store secrets in that cookie cutter project model.
Yeah, so that's called load env. So let's see, we're moving. It's called load env or .env, but there is actually a number of different ones. Sorry, I wasn't really. Yeah, it's called .env anyways.
Yeah, okay, cool. Then another one was around, is it possible to use some dependency injection and IOC stuff in Python, or is that not a Pythonic way of doing things?
Yeah, so that's actually a very interesting question. We're investigating that in our current project. And yes, there is definitely ways to do dependency injection. You don't have interfaces, so it becomes a little bit difficult in that sense, but you can do dependency injection. The question number 2 on that is that not a Pythonic way to do things? No, it's not a Pythonic way to do things. And I'm kind of opposed to using dependency injection for that matter in Python, but I'm also interested and willing to be proven wrong. I can't hear you, so I'm not sure if you're muted.
I was on mute. Yeah, another one was, what is the best way to integrate C# and Python? And my follow-up question to that would be, would that be something that you would want to do?
So that is also interesting. That's something that we're also investigating in our current project, mostly because we have a situation where we have to run some C++ things on the edge, on where we're using our machine learning models. And yes, you can integrate them using Cython, for example. And sometimes, actually, it turns out that it's sometimes faster to work with Cython than regular Python. In fact, quite a bit. But it also introduces a lot of overhead. So there's a lot of template code that's generated by converting Python to Cython. So it depends a little bit on, we haven't really discovered yet if we think it's a good idea or if it's going to cause problems if there is a bug, for example.
Yeah, and related to the same thing, would you use ml.net for something in C# and then combine that with Python, or is that also?
Oh, sorry, yeah, so sorry, I think I answered the wrong question before. Cython is for C++ and Python, not C# and Python.
Yeah.
I'm not sure if there is a combination of C# and Python. In fact, I don't think so. And as far as like, would I use ML.NET combined with Python? I haven't tried it. I can see that someone might want to do that, but Python has so good machine learning libraries and things that you don't necessarily need ML.NET. I would see ML.NET more as something that you would use if you didn't want to use Python.
Yeah. All right. One more, or at least three more even. One is, when do you feel notebooks are actually useful? Is it only for learning purposes, or is it also for the usage scenario where you would use a tool like LinkPad, for example, in .NET world?
Yeah, so I use them actually in the beginning when I'm exploring data. So when I'm looking at things like how is the data distributed, like for example, like yeah, bringing up a bunch of plots and diagrams and things like that. I find it really useful for that, and I do use it for that. But anytime it moves over to something that goes into production, like creating your models and things like that, I no longer use it. But I do think that, and I don't work with this a lot, but for example, with Databricks or Spark, you might need notebooks there.
Yeah. Cool. Yeah, and then a final one, which is actually 20 questions wrapped into a long, elaborate question. And that is, how hard would you say learning Python is? If you come from C#, what could people expect before they feel confident in the language? And also, on top of that, would you have any book recommendations or resource recommendations, one or two, where people
Yeah,
can...
absolutely. So I think like reading Python is super easy. Like you can do that now coming from C#. That's not a problem. Like the list comprehensions and things like that, it look a little bit odd, it might take a little bit longer, but C# is a much harder language, I think, than Python in that sense. But it's also one that's a lot more, like I like C# in the sense that it's a lot more structured. So when you write something in C#, you're less likely to shoot yourself in the foot than with Python. So writing good Python takes a while. Writing Python takes 0 minutes, if that makes sense.
Right.
And as far as recommendations, so Dan Bader, D-A-N is his first name, and last name B-A-D-E-R. He has a lot of both blogs and things like that for, you know, Python nuggets, like getting started with Python. But then there's like a lot of, you know, getting started programming schools on the web. And for machine learning, I really like Deep Learning with Python by Francois Chollet, the author of Keras. So if you're interested in that, that's a really good book, I think. And Machine Learning Mastery also, and that's a blog if you're interested in the machine learning part of it. But Dan Bader, I think it's called Python Tips and Tricks.
Cool. All right.
Yeah.
Thank you very much. I guess we can wrap up here. I think people should have your Twitter handle. It's basically Tess's name with an @ in front on Twitter. So if you have any follow-up questions or comments or feedback, feel free to reach out on Twitter. With that, thank you again, Tess, for presenting.
I appreciate.
Lots of great feedback in the questions pane here as well. I'll share that afterwards.
Okay, cool. Thank you so much.
And with that, let's switch back to my screen and mention that we'll be back in about half an hour with Formatting F# Codes by Florian Verdonk. See you, folks. All right, we see that Florian, our next speaker, has joined already. We're going to do a very quick tech check to see if the screen sharing and audio works. So bear with us, and we'll start the session at 5:30 Central European time anyway. So Florian, screen coming to you.
Okay, thank you. All right, can you see the slides? Okay, just check some other stuff. There's a browser window. Is that text readable?
Maybe zoom a little bit. Yep, perfect.
Okay, for the other tabs, that also zoomed, so that's good. Then lastly, check presenter modes. Like this, is that readable?
Maybe bump it up 1 or 2 scrolls on your scroll wheel.
Okay, like this.
Yep, perfect.
Is that going to be for all files or just for that file?
That's going to be just this one, but if you switch, you can always quickly scroll up and zoom in a little bit.
Yeah, okay, I'll keep it in mind. Thanks.
All right, perfect. Thanks.
Great.
All right, works. Let's switch back and yeah, we'll start the session in a good 10 to 13 minutes. Hey everyone, welcome back at the JetBrains.net Days Online. I'm Martin from JetBrains, and with us we have Florian Verdonk, who will be talking about formatting F# code with a tool called Fantomas. I'll let Florian introduce the topic himself, but before we go there, let's cover a few practical things. If you have any questions during the webinar, feel free to ask them in the questions pane. We'll try to answer the questions as we go along, and I may ask Florian some questions at the end of his session. But given the number of folks that are watching right now, we may not be able to cover all questions, but do feel free to reach out to the speaker afterwards if you want to follow up. This session, as well as all of the other sessions at JetBrains.net Days Online, will be recorded. So if for any reason you have to drop off, you can always check out the JetBrains TV channel on YouTube in the coming days. But of course, it would be very nice if you were able to stick around. With that, let's switch over to Florian for some Fantomas goodness.
Yes, hello there. My name is Florian, and let's just dive straight in. I'm very excited to be here. In this talk, I'm going to explain how formatting F# code works in Writer. We can see this in action. I recorded a little video where I'm inside of Writer. I'm in Zen mode. There's some source code. I open the action panel. I search for that reformatting code and let the magic happen. Under the hood, a library called Fantomas is being used to achieve this. And this talk, we're going to see how does Fantomas high level work, how did I get involved into this project, and how is it integrated in Writer. So first off, what exactly is Fantomas? It's an open source community project that was started somewhere around 2013. It takes F# source code and it completely reformats it in a standardized way based on a given configuration. The project was started in 2013 by Ang. It was released as a command line tool and a Visual Studio extension. The name Fantomas is referring to a character in fictional works of Pierre Silvestre and Marcel Alain. There used to be a running joke that all open source F# projects start with an F, so that's where the name came from. It was a beloved character by Ang, who created it. Fantomas also has the same Greek root as the phantom, which kind of fits the narrative since formatting F# code can be very mysterious. So to put it simple, all Fantomas does is it takes a plain string and some configuration that returns a string. Obviously, there's more to it, but let's dive into it. Fantomas uses a library called the F# compiler service. This is the F# compiler, but shipped as a NuGet package that exposes some different APIs from the compiler. When you compile F# code, there's a series of phases that happen before you go from text to a binary file. Fantomas uses two of those phases, being the parsing phase and the lexical phase. We'll try and get to have an abstract syntax tree, and based on that, try to reconstruct the code in a formatted way. There are four main building blocks when it comes to this. So the first thing is to get that abstract syntax tree. Second thing is trivial, which I'll get to. And if you combine those two, you can create writer events. And at the end of it, we sort of merge everything back together and output it to a string or to a file based on what being called. This isn't the exact order, but that doesn't matter. We'll get to that and you'll get the gist of it. So let's take the following F# code as a snippet. You can see here that there's a couple of things present, there's some comments, there's a binary value, etc. And the best way to illustrate all these different phases in Fantomas is by going to an online tool we have. So full screen in the browser here, we have that same code snippet. I have on my left my source code, and then on my right I have some tabs which illustrate everything that happens in Fantomas. Maybe let's first go to the last tab where you can see the formatted results. Over here, I also have a button, looks wrong, create an issue. That's something I kind of want to tell. When we go to that, we go to a GitHub page where we can create an issue in the Fantomas repo. Let me just zoom in a little bit. And what this basically does is it shows your inputted source code, it shows the result, and then you can describe here what your problems are, and we also capture all the settings you have. So if you go back to this first example, this was the output. How do we came to that? We looked into the AST. So we have like a view, what's the raw AST tree that you get from the compiler. This may look a bit challenging at first, but there are like some things you can sort of recognize. This based on the F# type system. So the F# compiler is written in F#. So these are F# types, and this is the string representation. This is basically giving that tree to string. You'll see that we have a type definition, for example, which has a record. The type definition, it is called format config, so we can sort of link words together. So that kind of makes sense. Then there's a let binding over here, which has a constant, you notice constant t, so named wild t. So this can be challenging at first, but you can sort of see where this is going to. Everything also has a range, so we can see, oh, this is happening on line 8, and then we can put one on one together. And basically, we traverse this entire tree and process back outputted code. If I go back to the slides over here, we can see that we also have 2 comments. Let's look at those in our AST tree. If I were to take this first bit and search for formatting code, you might hear my enter, but there are no results. So turns out not everything is part of this AST tree. If we look at code comments, those are actually not necessary for F# code to compile to binary, so they're not stored in the tree. And if you look at the results, we did manage to format that comment back again. So how did we do that? We also use a tokenizer from the F# compiler, and that basically takes your input string, takes your text, and then says, okay, this little chunk is this piece. And if you can see on line 1, we have like line comment chunks. If I open one of those, we can see these first 3 slashes are a comment. That's a comment token, and we sort of detected this. And what Phantomus does is it scans through all the tokens and sort of identifies things based on patterns. And those patterns are, we call them trivia. A trivia is then something we found in the tokens, but not in the F#, in the AST. So we have a comment here, we have a new line. So there's no mentioning of new lines in the AST tree as well. We have a number here, which is a bit of a special case. So number is part of the AST. So we saw that if we go back, the number t, or the variable t over here has a constant, has an unsigned integer, but the format is different. So I have something in hexadecimal over here, and on line 41, it's already an outputted integer. So we detect those as well, because if we look at the restored codes, we do preserve the original style here. So those trivia then need to be assigned back to the trivia nodes, because we traverse the AST tree, so we need to assign them to the things we know that are there in the tree. So if you look at the record, for example, it has a comment after, which is the case on line 6 here. We have the let binding, which has content before. There's a new line before that let binding. Or we have this constant here, and the constant itself is actually something else than we found in the AST tree. And that's kind of how we puzzle those things back together. When we traverse the tree, we create something that's called writer events. Instead of having some sort of a string builder and printing everything directly to the output, we sort of collect instructions first. These are called the writer events. We do a little sort of event sourcing thing there, where we collect all the events, which is most likely write this file, but also add some extra spaces, do the indentation, unindent, etc. And after we have all these things together, we can actually construct the results. So let's see this in action. I have the Phantomus solution open over here. If I were to go back to code formatter, this is our public API. I'll actually try and debug this. I'm debugging the example I had in my online tool, and the online tool is based on the same source code as Phantomus. So it is a web application that calls some Azure functions. Those Azure functions then use the exact same code as Phantomus. So we should see all the same things pop up here. The first thing that we notice is that we have this format document. Our source string is the same as we can see. So it has the, well, it has the type, it has the binary value, etc. Then the next thing we do is that we use the F# checker. So that's part of that compiler service NuGet package. We use the checker to get the abstract syntax tree. Once we get that, we collect trivia. So there's the tokenizer. We tokenize the entire file as well. We find that trivia. We assign the trivia to trivia nodes. This happens over here. We can also see that we have a configuration. So I'll get to that in a moment. And then we start traversing the tree. The top level was an implementation file, and Phantomus has a lot of compositions and custom operators. What we basically do here is that we have a function that has a context, and it returns a context as well. And in that function, it adds the writer events. So then basically you put all these little functions together in a nice composition in an entire chain, and that's how we walk the AST. At the end of it, we have collected all the writer events. So if I look in that context that's been passed on from function to function, I can go to my writer events over here. If I look at those results, that's we don't have a tool for this. This actually works pretty well, but you can see everything we encountered. We're writing stuff over here, but then we're also indent by 4 spaces. So the 4 was based on the configuration. And then when we continue, we dump this into a string again. We have results over here. And that was our formatted code. So in a nutshell, that's how Phantomus works. Now, I briefly skipped over it, but at the end, we saw that we actually could have multiple AST trees, and we can pass along defines to our compiler that highlights certain code paths. Maybe the easiest way to explain this is going back to the tool. I have this piece of code over here. So this hash if, based on if you pass foo to the compiler, the value of a will be 8, otherwise it will be 42. And from a compiler's point of view, you can also see this in each phase. So if we look at the F# tokens that are produced from this code, if we just go with the default compiler settings, we see that we don't have a line 3 here. So foo was false in that case, and it didn't even print anything out. I can enter my define. If I were to pass foo, then you see that, okay, I have a line 3 now, but I don't have line 5. And if I go to the outputted results, Phantomus actually was able to take both code paths and merge them back together. So the same thing for the AST. If I were to look at over here, I'll see that my constant is 42. So that means foo must have been wrong. If I were to enter my defines over here, I can see that the constant is now 8. So basically we take 2 trees. If I go back to the source code on the last, we take 2 trees over here, and then we sort of merge them back together. And each time we need to make a decision, which code path do we take? We sort of take, well, the one that's not empty. And yeah, this can be pretty challenging, as in my simple example, I just had like one compiler defined foo, but you can also have some Boolean logic, and there we have some sort of an expression solver that tries to determine all the possible code paths, and it can take up to 8 combinations, 8 trees, and then merge them back together. So it's pretty interesting stuff that we're also able to format the dead code, so to speak. The next thing, Phantomus allows for some user settings to determine how the output looks like. So in the next example, we have this record over here. This didn't really change that much, but we see that we have a type over here. I'm actually sneak peeking a new feature that's coming for the next release. I have the setting multi-line block brackets on the same column. If I put this to true, then I can see that the way my type definition and my type record here was formatted differently. So the brackets now align instead of being nested right next to the body. This is an interesting case. So based on some configuration settings we can see over here, some more obvious are the indentation space. If I try to put this to 2, for example, if you're more into that, you can see that the indentation changed along the way. So we have some configuration that controls how the writer events are created, but it can be challenging because when you sort of think these things through, you need to take all possible values in the AST tree into account. So it's not just about formatting how a record looks like. It is, in this case, it's a record based on the type, so it's a type definition. But then on the next thing, it's like an instant of a record. Then a bit later, it becomes an object expression. So let's see, object expression is also over here. Some expression. So we need to take all these cases into account when you format the entire tree. So that's why settings can be really tricky, and we're a little bit hesitant of introducing those because some have a clear scope, like indentation. You can't really do anything wrong. You just need to have to take it into account all over the place. But for those record syntax, you really need to think it through. Where am I going to allow this syntax and not? Where I'm going to have different behavior. But in a nutshell, you can sort of tweak these settings in our online tool. And then if you did some tweaking, there's this copy settings button, which copies settings. And if you were to use the command line client, we'll get into a bit. The copy settings actually basically copies what you needed in a JSON format, which you can then use later on. So how does one use Fantomas? I mentioned it's integrated in Writer, and we'll get to that. But when we release, it is released as a NuGet package library, DLL, and a command line tool. So in that command line tool, you can then use it, just to format with a configuration file. Or if it's in the library form, other projects can use it. One of them, the most popular example, is FS Autocomplete, which is like the language service that powers the VS Code plugin. And then the other best example is Writer itself. So we'll get to that, how this can be used. First, let's just dig into how does it look like as a library. I said, okay, the input is always a string and it returns a string. That's in this FSAST, which is a helper thing to let us construct AST nodes. We're basically going to take this little snippet and try to create AST nodes ourselves. So this seems a bit strange at first, but what we're trying to do is we'll recreate this tree we see on the right here for this piece of code. So we're going to create a left binding in addition. It has an A and a B, and it sums them up. If I go back over here, we'll take a module declaration because everything in F# needs to be in a module. We'll have this create let. So this is the FSAST there. We can have some helper functions to construct this AST. We see that we have an input called AB. We have a function name. We have then the actual calculation, which is an operator. So, well, I would say don't try this at home, but it is kind of interesting where this can go to. So if we look at this AST tree, it is exactly or more or less the same than we had in our online tool. So the only thing that's really different is that no ranges are matching here, but that's because it doesn't have any source code to go on to create ranges. And if we were to then open Fantomas, I have the latest stable version on NuGet here. If I use the code formatter API over here, code formatter, that's like our public API. The most common things are like format this document, format the selection, but there's also this format AST. And if we format the AST, we actually can generate code ourselves. So that's also pretty interesting. So this is like the school example, but I also had something else in mind for this. If I have a little project SQL type generation, I have a database over here. So some simple stuff. I have a base database with a table users and a table tweets. Then, I just created some seed data, but it seemed interesting to grab the table definitions and create some source code based on what I found in my database. So if anyone used Entity Framework like a couple of versions ago, it's like that database first kind of vibe I was going for. I created the fake scripts, and I'm going to use a NuGet package called Dusty Tables, that just to create some SQL expressions in a functional way. This is like the code we want to create. So I want to create a file where the type matches my user, my table, and then I have a get whatever my table name is, where I do a SQL query, and the column information and the type definition are just based on what's in my database. So if I first of all, I do some little helper function to get just a SQL, the table name, the column name, the data types. I get these things from my database, and I'm just going to generate code similar to the first example we saw. We're going to create AST ourselves with the helper function again. Let's just see this at the end. So first we're generating the AST, and then we're using Fantomas to format that again, and then we'll have our database file, and then we'll see what that does. Look at the generated code over here. We just try and get the table information, create an implementation file. Then I collect for each user table I found. I generate some code. Over here, I'm creating the type declaration. So there was a user table, there will be a user type. There was a tweets table, I think, so there will be a tweets type. Then there's this getter. I'm creating a lambda expression to sort of get the fields. This is interesting stuff because it's like a nice parallel to the feature that shipped in the C# compiler or something in Roslyn, where you have like plugins to generate code, but this would be like the equivalent, and it's part of the F# community, so it was already kind of there for F#. So if I were to run this, I can just execute my fake file .NET run builds. No, need to go to the correct folder first. I'm just going to run this. This is my little application. It's going to create this database file. Okay, it already did, but I added a timestamp just for reality's sake. And this just created code I needed or I have in my database based on my SQL file. And then if we were to run this program, it just gets the tweets by the generated code, which just does a simple select query, but I didn't have to define this tweet type myself. It's just based on what it found. So that's also a very lesser known use case of Phantomus where code can be generated. The Myriad project is the best example, I think, there, that does the meta programming stuff and at the end also uses Phantomus to output the generated code. So that kind of builds up to how does Phantomus then work in Rider. The F# support in Rider was made possible by another open source plugin. There are two major components to that plugin. One is an IntelliJ plugin written in Java and Kotlin, and the other one is like a plugin for the ReSharper host, which is the backend servers that powers Rider. As you might expect, well, the usage of Phantomus will just be the ReSharper part that uses the DLL and then does the formatting like that. But there's a bit more to it, and I would just like to show this in action because this is actually pretty cool if you download that package. If you were to clone the ReSharper tooling for F#, you can just do this. This is the ReSharper solution. So this is really the ReSharper plugin. There's also the Kotlin stuff. I'll just run a sandboxed instance of Rider. So this is really cool. I can do like a Gradle W run IDE over here, and this will start a sandboxed instance of Rider. So actually, it's very similar to an early access preview. It's gonna boot Rider, and then later we can attach to the backend service to that process. And there's a format over here in F# PSI features. There's one called reformat code, and that's the thing that's being executed when you reformat your F# code. So we'll get that same tree over here, and we'll create the Phantomus settings. Then we'll check if there's a change, if a selection was made, or is it the entire file. And then based on that, we can see if there are no defines, then we actually already have the AST node, so we can format the AST there. Or otherwise, we need to do that multiple tree formatting process, and we can call another API, the code formatter. So I think this is running now. You may not see this right away, but this is like version 2020.2 AEP1D. So this is really like a debug version. If I were to open that same solution file, and then let's go back, and you can see that this is running. We can then go back and try to attach to the process. Now I need to be really careful which one am I using. So this is my C project, Rider F# support. That's my repository of the plugin I cloned. it is attaching to an already running process, which makes sense. So this is my code over here. So this is the code I generated myself, but well, confession time that there's like this indentation, this pipeline. That's not nice, and that's because it was using an older version of Phantomus. This has been solved by now. So if we were to format this in the sandbox plugin, we'll get a better result. I'm just gonna wait just a bit longer until I'm really sure that it's all attached. And now let's just try this. So if I open the menu here, I go for that reformat code. Then we hopefully, yeah, we hit our breakpoint. Okay, that's good. And then we can basically go and drill down. And this is just like really cool that this plugin, this IntelliSense support, everything F# related is just developed in the open. You can test out new features ahead actually if you want. We see that we're getting the checker service if necessary. We're just building everything up. We're getting the formatter. So again, I get my settings, and I'm expecting we can format just by the existing AST nodes. These AST nodes are also like used for IntelliSense and code completion. So that's why most editors already use the compiler for that stuff. That stuff is already there. So it makes sense to also use Phantomus. There is no range marker, so we're not going to try the format selection stuff here. There are most likely going to be no defines, as I'm expecting. Oh, there are defines. Okay, well, wasn't really expecting this, but even if we're making new AST nodes with the compiler, this all goes very fast because the F# compiler serves NuGet package internally also is optimized for that. So it will already have like a cached version if nothing is changed. So even though we are getting new AST nodes, there's already some optimization in the background just by using the F# compiler as is. And then we get our formatted codes, and I think I can show you this. Let's see, formatter. Doesn't exist. Let's change. I should probably be able to see this somehow. Yeah, sorry, I'm looking over it. So this is changed. Okay, here we are, I think. View, yeah, this is the file that's being changed. So writer is gonna know by this change. I don't really know what happens after this, but it's kind of the change was being like published, and if we then go back, then we can see that our pipes are aligned here. So we definitely formatted this code. So this is nice to see how that exactly works. Okay, going back, I'm going to stop my attachment and stop the Gradle process. And we can go back to the slides. So I mentioned Phantomus uses those AST nodes, Writer uses them as well, but actually, if you do all the cool stuff with Alt Enter in Writer, you're not modifying AST nodes, but you're modifying resharpen nodes, and these are really like the next level. So they're initially created based on what's found by the AST and F# compiler, but the AST format that resharper uses handles multiple languages, and it's really more powerful. There's a parent-child relation, so you can do more stuff with the resharper nodes, and all the IntelliSense is like based on those nodes. So it sort of brings up the question: will Writer forever use Phantomus? And the answer is a maybe, because they also have their own internal project structure, and it's going to be interesting to see if they can also like create a fully functional formatter with resharper nodes. So that maybe is a bit like future music. It's a bit impossible to say at this moment. Oh, where is this heading? But it will be cool to see if there are like two formatter solutions for F#. I think some competition is good. People can learn from each other, and it will lead to some innovation on both ends, I think. Another part of this talk is the story of how I got involved in this project. As I briefly mentioned, I did not write Phantomas from scratch. I merely continued the great work of others. And this part is like the story of how did I get involved in open source and what's the road to the ownership here. Our story begins in a pull request in the .NET F# repository. Someone proposed to migrate the code base of Phantomas directly to the F# compiler, which in itself is not a bad idea, as Phantomas heavily uses the compiler. To format code, it makes sense to have that close to the compiler itself and maybe even part of the NuGet package. If it is part of the F# compiler service, then everyone can just call it as the formatting service as they call the tokenizer, for example. Don Syme wrote his feedback in this pull request, and he basically wanted to only merge the code if it was possible to format the compiler itself, as the F# compiler is, well, the largest publicly known F# code base. So if you can format the most difficult thing, it's probably going to be okay to adopt. Back in the day, Don held something called the F# compiler hours, which was like an hour you could ask him questions on the F# Foundation Slack channel. And well, I was interested in this kind of thing, but well, I was pretty a novice at that point, and I asked Don any progress on this. It was like, well, it was like definitely the wrong question. I was sort of expecting Microsoft to pick this up because it's, I don't know, it's Microsoft. I sort of assumed that they had like a army of engineers, and Don basically said that it's up to the community to pick this up, that the F# team has other priorities, and well, it was like a normal reaction, but I, at the time, you know, the man that had proposed this pull request didn't update, didn't keep this pull request up to date, and sort of the effort got ceased from his side. And sometime after that, I enrolled myself in the F# mentorship program. At the time, I was like working on F# and the functional program for like a year and a half as a sort of a hobby. I was into F#, I was into Elm, and it felt like I understood the basics. It was time to move to the next level. For those who do not know, the F# mentorship program is an effort of the F# Foundation where they try and pair newcomers and more experienced people. You can like sign up as a mentee or a mentor. Then you get paired based on a time zone and based on what your interests are. And then you have like someone you can reach out to and collaborate. I was fortunate enough to be paired with Anthony Lloyd. He's a fine British gentleman with a lot of expertise. He writes F# code for a living. He's one of the maintainers of the F# Expecto test runner. And we initially were supposed to start our mentorship thing. We were paired. I just moved to a new apartment and it took some time to get settled. So I actually almost blew off the whole thing. It was just one of those phases where I just didn't have the energy and the courage to do this. I postponed our first meeting, but a bit later we eventually had our first Skype call. After introductions were made, the main question popped up. So like, yeah, what's the game plan here? And we didn't really have to tell up front we're going to work on this. We just had to generally give our interests and our time zone, and then they paired us. So I told Anthony, yeah, I was like really impressed how F# community really does a lot of things themselves. It was quite a contrast when I come from a C# background, and I feel like there are a lot of people look at Microsoft and then stick to what they propose that you can do. But the F# community sort of does things themselves, and I wanted to be part of it. I wanted to contribute myself. And I told Anthony I had some interest in the Phantomas project, as one of the things I was really missing when I came from a bit more of the Elm side. Elm has a great formatter, and well, F# and Elm, their syntax is just a bit different than what you're used to from like a C# or a Java. So it really helps that you have a formatter when you just don't need to worry about how should it look like or etc. You can just, you know, hook up the formatter, it formats, and then that's the end of it. So that's why I took an interest in F# in the formatting project Phantomas and looked at that pull request. And well, we started out by simply fixing a bug. At the time, there were no like debug tools, and I didn't really know what an AST was, to be fair. It was very challenging. Phantomus also heavily uses active patterns and custom operators, and well, it was really challenging for me as a newcomer. It was pretty confusing as well. And truth be told, I was really in over my head. But yeah, we were able to solve that first bug. But as I mentioned, the project was like having momentum in 2013, so it also had that still old MS-build syntax. So the old .NET world before .NET Core and stuff. So that's one of the first things we tried to do. Let's try to elevate this back to the new world. We wanted to move to that .NET Core experience. And we also update the F# compiler service because it was been a while since that was updated. And I received the NuGet keys from Ang. So yeah, the first thing we were able to do was like have this first release of, okay, this is now a project again. And it was an exciting moment. I slowly began to realize that, I might end up maintaining this, but yeah, Ang was really happy that someone continued to work, and then the source code was under his account, so we needed him every step along the way for pull request review. But yeah, we kind of did it. And all good projects need some buzz to get the word out. So I wrote a little blog post. I wanted to let people know that, hey, we're trying this Phantomus thing again, and it's part of our mentorship program. And the news was well received. I was doing a nice thing, and getting that first release out was a great closing to our mentorship program. I parted ways with Anthony, and I felt comfortable enough to move forward on my own. I learned a great deal from him, and both on the F# coding practices and on how to maintain an open source project in this community. So about a month later, I had the opportunity to go to NDC Oslo. My employer recognizes the benefits of conferences, and it was a great place to learn a lot and to meet some people. And somewhat randomly, I noticed that Don Syme was sitting in the hallway. So pretty nervous, I approached him and I told him, hey, I'm that guy and I'm doing things with that Phantomus project. And he knew the project and he was grateful and said, yeah, this is good. This is interesting. And we had a good conversation, to say the least. And the lucky thing there is that he knew Ang. He knew Ang personally. So he reached out and he said, hey, this guy wants to do more with that project, wants to have it continue to evolve. And could we maybe move this from your personal GitHub account to the FS project? FS project is like the incubation space for new ideas that the community comes up with. It's not the only space, but it's like a good organization. It has a lot of things. I think Packet is under there as well. And Ang agreed after Don reached out, and I sort of learned that Ang isn't doing anything with F# anymore. And yeah, it moved to FS project. I got the administrator right, so I was able to tweak some CI settings as well, and all was great. Now, I'm not truly alone in this story. There's also another developer that contributed to Phantomus from every now and then, and his name is Jindrik Ivanik, and I'm happy to call on my friend and my partner in crime in this Phantomus project. We first physically met in FableConf Berlin in 2018, and it was really exciting. I mean, we were sort of two strangers who talked on a Slack channel every once in a while, and we've been working on the project, but since we physically met, things really kicked off. So I don't recall the exact order, but at some point on Slack, I asked him, hey, you want to be co-maintainer of this thing? And he said, yeah, sure, why not? He had a similar point of view where he said like, hey, I want to do something back for this F# community, and Phantomus was that thing. And it was great because he knew the project as well as I did, and we had like sparring partner there. When I got stuck, I could ask him for questions, or we had Skype calls like, hey, how would you tackle this? And if you look at this picture, it's not Berlin, but this is Antwerp. 1 year later in FableConf Antwerp, we met again, and it was like great to see how far we came, how good it was for the project to physically meet. Ever since we met, we sort of created this idea of this online tool where you can report issues that gives us enough information to go on. So this is an early version of the tool I had in the beginning of the talk, and they used to be separate things. It was like an incremental thing that we first had the formatting tool just to report issues, then we had the AST viewer, and etc. And lately we just merged them together because every time the F# compiler NuGet package bumps, then well, not only do we need to take it to account into Phantomus, but also update each individual tool, and it was a bit of a hassle, so we kind of moved them together. But yeah, it was really getting momentum, I feel. And after some good collaboration with Jindrik, other people weren't submitting pull requests as well. I initially saw this nothing as good news. More people involved could only mean that there's more growth for the project, and I was a bit too eager. I kind of made a mistake by merging a pull request too quickly. The code looked okay, and the guy who submitted this, he had a unit test and good intentions, and I definitely don't blame him, but we sort of introduced a new setting, which is preserve the end of line. And yeah, that led to a lot of problems, and some were really like unfixable to get to say the least. And yeah, no hard feelings, but someone I don't know merged some code I eventually had to maintain, and it caused a lot of problems. So that I kind of learned something that day, that I need to be more careful what I merge in. So what this setting did is that before the whole trivia story, we actually compared tokens. We took the original F# tokens, which would contain comments and everything we saw, and then the formatted tokens don't contain the comments and new lines, and then we sort of merge the two token streams together and try to have some sort of a result. That's that works in most cases, but there were just some things with that setting in mind that if you didn't stick to the default configuration, it just never could have worked. So there's definitely a life lesson there, and it has been bothering us. We couldn't really move forward, and we wanted to get rid of both the way the token streams were matched and that setting. And Jindrik talked about our problem to Don Simon at another conference, and he mentioned that, well, the AST on itself doesn't have enough information. So that's where they came up with that trivia idea, like, what if we store extra things in the AST, like the comments as is, and new lines? And the idea seems very great. It was a relief that we could get rid of the token matcher, but it meant that we had to impact the entire code base. So this led to our first major release, which was a massive amount of work, considering everything that transpired. So yeah, both Jindrik and I were doing this as a hobby, so we didn't really know when are we going to tackle this. And I work for a consultant. For the most part, we do time and material, where we support customers and existing development teams. So basically, we have a lot of customers that do C#, and well, then I also have to do C# to support that team. And well, it wasn't all bad, but it just lost all the sense of wonder. If you go into that F# rabbit hole, you never want to go back. And one of the benefits we have, of course, is that we can switch to new opportunities. I live in Belgium, and there are just very few companies that bet on F#, so our sales department had no idea where to go, or didn't really have any leads. I follow the F# job channel in the F# Foundation Slack, and every once in a while some job offer pops up, and I sort of just slowly check it, and yeah, mostly it's not a remote position, and that brings us back to square one. And yet an unexpected opportunity arose. The people of G Research were looking for someone to invest resources and improve the F# ecosystem in general. They have teams that use F#, and they acknowledge that the state of the F# ecosystem isn't always perfect, especially if you compare like tooling to other languages. So they wanted to make a difference and fund some project or an individual that could pick up things that the team was currently missing in their everyday development. It was a bit of a long shot, but I reached out to them on Slack, and we came into contact. I explained my story, and yeah, there seemed to be a match in what I had to offer and what they were looking for, because they have a strong opinion on how F# code should look like, and a tool like Fantomas could be the right one for the job to enforce it. The fact that I already knew the code base was also a very compelling argument, and I told them about the major release that was coming up, and yeah, they definitely saw the benefits. So there was hope. After some negotiations, G Research and my company agreed to a short contract, and one day in the week I was allowed to work on Fantomas during company time. I was getting paid to write F# code, and it was really the best experience in work I've ever had. It is something that you're so deeply passionate about, it doesn't feel like work at all. It's an amazing experience, and it's rewarding on so many levels. At the halfway point of the first contract, I presented to the team what my progress was. On the left, we see the team based in London, and on the right, there's the manager of G Research. So they sponsor multiple open source projects. F# isn't the only thing they bet on, and it was really helpful that I could reach out to him, to the team. They showed enthusiasm, compassion, appreciation every step along the way. Even when I had like non-technical issues or general open source questions, I could really count on them. And yeah, then Phantomus 3 was slowly becoming a fact. We we of course need to blog about these things, and from time to time I do blog on our company's blog. And I sort of have this rule of thumb where if I have the adventure during company time, I'm willing to put it on the company blog. If it's something that was in my spare time, I might prefer my own personal blog. So it's nice to see that, well, there was a transition from my hobby to my company, to work actually. So even in those blog posts, so it became a work thing. And well, my work isn't concluded yet. So the refactoring that happened in version 3 isn't really sufficient for G Research. Phantomus follows the F# formatting guidelines by Microsoft. And if you look closely at the screenshots, these are based on formatting guides by Ang. Ang, who is the one who created Phantomus in the beginning. So the fact that we follow these guidelines is a bit of a self-fulfilling prophecy. So the guide Microsoft has there is slightly altered, but it really didn't require that much changes in Phantomus to adhere to the style. And well, that's also a bit the downfall that, well, this coding guidelines were created somewhere around 2019, but F# has been a thing since, yeah, I don't know, let's say 2005, maybe 2008 publicly, who knows. So yeah, it's a bit late to have a guideline, but it's never too late. But people have like other opinions on how we should format the code. And G Research was also in that team. They have some other stylistic decisions where they say like, hey, no, we've been writing F# code for years like this, and they sort of formulate it, or they have their own internal style guide. And I asked them, hey, could we maybe publish that? And they said, yeah, why not? And then version 4, which I'm now working on, is basically trying to have some settings where you can end up adhering to their style and guide. Now, that doesn't mean that G Research is calling all the shots in the Phantomus project, definitely not. But they have been doing this for years. They have an opinion, they have like an idea on if we have this setting, where does it apply? Like the example I gave for the records, they really could say, oh yeah, but it happens there, there, and there, and there. And if you then look at it from an AST point of view, it was always pretty complete. So that's why these settings they asked kind of were easy to align, because you perfectly knew where the setting starts and where it ends. But it was all just based on a community effort. Like, hey, we want people to have the possibility to format as we do it, and by doing that investment, they sort of improved Phantomus as a whole, because I've been working towards their formatting conventions, but obviously just fixing bugs for everyone. If they report a bug and I fix it, it's a fix for everyone. So there's definitely very good things coming out of this. And there is an alpha of the version 4, so that's not in Rider yet, because well, Rider has a fork of Phantomus. They have a slightly different version, the compiler, so they sync every once in a while before a big release. So you don't get the latest and greatest within Rider, but that's also a good thing, because well, every new version tends to have a little slip up here and there. So Rider always depends more on a more stable version. And yeah, version 4 is looking promising, and I feel really supreme at this point. I've reached that point where I have like all the knowledge, and I feel like I can tackle every problem whatsoever. And well, that's great, but that's also a bit of the part of the problem. There's only like 2 people who know the entire code base, and that's a bit problematic. If I want to take a break from Phantomus, it will appear that Phantomus takes a break as well. And that's not really what I want. One-man armies don't scale that well, so for that reason, we can never cover enough ground with the people involved in the project right now. So we should try and pursue other people to have a look at Fantomas as well, and maybe consider fixing their own bug. So yeah, it shouldn't be a one-man show. That's always a bad idea. So in that case, I kind of want to grow beyond that and maybe pursue even other ambitions. So I definitely want to take a stab at some writer tooling at some point, because that's also very interesting stuff. So I want to be more than the Fantomas guy. And that's why this year I had this idea of the road to adoption. It is a very fancy name just to get more people involved, both in using the tool and then reporting bugs and also contributing. But I created a YouTube channel where I made detailed videos of how does this work. And most of these start with a problem that we see. And the first episode, okay, there's just a problem in the AST, something we misinterpret. And then we slowly move on, like how are those contexts, how are those functions chained together? Then there's the trivia, what the devil is that? And it's becoming a sort of a form of documentation which is lightly digestible. And I've been working hard on getting knowledge sharing of how the tool exactly works. Because give a man a fish and you can feed him for a day, and teach a man to fish, you can feed him for a lifetime. So I really want to teach people how to solve their own problems if they might occur, if they might have some with Fantomas. So I really want to go from one man on the top to a real herd, that the F# community comes together. We can cover so much more ground, and it's actually interesting to see, because last week I sort of asked someone who created an issue. I said, hey, I looked at the online tool. This is going wrong over there and over there. If you watch this video, you might have a notion of what to do. Would you be interested in solving this yourself? And well, I created a couple of those summaries of how it should be solved. And some people say, yeah, sure, why not? I looked at the video. It's kind of clear to me what to do. And they just, with a bit of my guidance, they were able to solve their own problem, which is like really an interesting take here, because it's very slowly we're getting to that picture that we're starting to get a herd, and we'll be able to cover that much more ground. So the key takeaways of this last part of the story is that everything can pick up a complex project. I went from zero to hero when it comes to this. I knew nothing about the F# compiler back when I started, and now I can say I know a thing or two. Goodwill and enthusiasm are fine, but sometimes you really need that extra push in the back when tackling complex things, and G Research really was able to provide me that. So it nothing but gratitude for that. And next to the technical things that went over this, I also overcame some of those personal challenges. This talk is a nice example. It really motivates me to, to step up and then try and get the message out. And though the road is still a long one, I hope that Fantomas can one day be stable enough and really format that F# compiler, because that will be the destination, so to say, and it can go to the F# compiler itself, and that's still the dream. So it has been an incredible journey. To wrap up, just a bit about me. I am Florian. I work at a company called Axis. You can find me on Twitter or on GitHub or the F# Foundation Slack. For those who are clever and can put one and one together, if you ever need anything F# related, toss a coin to your Witcher. That concludes my talk. Many thanks, JetBrains, for having me, and many thanks, everyone, for watching.
Awesome. Thank you, Florian. Very nice session. I have a couple of questions from the audience that you may be able to answer. And let's start with a, I hope, easy one, which is there any significance to the indentation coloring that you have in Rider?
It helps in a visual tool, because F# is indentation sensitive. So it's just a plugin I use that works for multiple languages, but I found it helpful. Then you can see how that works. So this is nothing Rider related, just a plugin I like to use. So I don't know if that answers the question.
Yeah, I think so. Which plugin is that? Is that Rainbow Brackets or?
It's not Rainbow Brackets. I think it's Rainbow Indentation. Let me go quickly check that out. Indent Rainbow, that's the one.
All right, cool. Thank you. some other questions. One is the question about whether it's possible to use Fantomas on a CI server for a team code style check.
Yes, a very interesting question. I actually have like a little example. Let me most likely over here. So Fantomas can also be, yeah, this is like the trivia tool. This is this tab, which used to be its own product. And if I go to my GitHub Actions, let me zoom in a bit. I have this build file when I call what are those fake builds. So we run our whole CI/CD process in the build file. And if I go over there, there's something you can do that's possible in both the command line tool and in the fake helpers. If I go to there, there's this thing called check code format, which you can call the public API fake helpers check code, and this returns an error code if you if some file isn't formatted correctly. So it formats everything, and then it checks if there was any change in before and after, and it throws exit code 99, I believe, if one of the files needs to be formatted.
All right, makes sense.
If I were to go over here, so just using the Fantomas CLI with a help, there is Fantomas. Yeah, there's a check flag over here you can pass. So that does the same thing.
All right, cool. Then the other one is, can Fantomas format code that won't compile?
Yes and no. Yes, in the way that if the syntax is okay, it can format it. So let's go back over here. If I say let A is B, we do not need to know if B exists. Because the syntax is okay here, the F# compiler can make an AST of it, and it can it can process the AST regardless of whether this will actually compile or not. So that's yes. But there are scenarios where if you, it's unlikely people will get to this, but if you do like A and B, and if you then say not A over here, if you were to have like these kind of constraints that don't really make sense, Fantomas won't be able to puzzle back everything together, and that's one of the things that even if, well, in some conditions it is valid code, Fantomas needs to be able to reconstruct every code path, and if it's unable to do that, it will fail. But your code as a general guideline doesn't need to compile. If it's syntactically okay, it should be okay.
All right, nice. And then the last question that I have here from the audience is a bit longer, and it starts with a premise. The premise is that many formatting tools these days are opinionated and do not provide any way to configure them by design, just like Fantomas. So developers don't have to spend time worrying about which coding style is the best and can focus on the code style itself. What do you think about that? And have you considered to not have a code configuration in Fantomas when you were designing it?
Yes, well, I sort of shifted in my opinion on that. It would have been nice if there were just like no settings and it's what you get, but it's a bit late in the game. For example, if we have like records like this, you can format code like that, but you can also put the brace over here, or you can even do something else. So there's just a lot of room for interpretation. And if Fantomas was to be released, the first ADF# compiler comes out, that would definitely be the way forward. One set of rules, that's how we format, and that's kind of what Elm did. So I think Elm has very little option and has very little room for settings. If I want to push in that direction, it's just been too late because people are used to different things. Research is a good example. They've just been doing stuff for, they've been formatting differently for a lot of years. So it doesn't really make sense to say, no, we're doing this opinionated. People just won't use the tool. There's still a couple of choices that do adhere to some style guides, but don't fit in what other people are used to. And then people say, yeah, it's nothing for me. So the Phantom as audience is a tough one by times. So a bit configuration is good. Too much is getting out of hand. It's about finding a balance there.
All right, makes sense. Yep, I guess we can wrap up here. Thanks again for presenting, and let's switch back to my screen here to announce our next speaker in half an hour from now. So thanks again, Florian, for presenting. I really enjoyed your session and hope to have you back at some point for another webinar. In half an hour, we'll have Khalid with a session called Starting a Blog. And I'm also interested in that because I have a blog myself, but I would like to see how today you would start your own blog and start building your audience, start setting up the technical aspect and so on. So stay tuned and be back in half an hour from now. All right, everyone, if you're watching the stream, we're not yet starting the next session. We're just going to do a very quick technical check to see if the screen sharing and audio works for our next speaker. Khalid's screen is coming your way. Let's try the webcam as well. All right, screen sharing works. Let's try audio. You're still on mute, Khalid, I think.
Oh, there we go.
Yeah, there we go. All right. All
Let
seems to
me
work.
let me try sharing my screen. I guess I couldn't play the audio while sharing my screen, so.
Oh no, that's an interesting issue. Yep.
Oh, okay. So I have to unmute myself first and then share my screen. Can you hear me?
Yep, works.
Okay, cool.
All right, cool. Let's switch back to my screen and then we'll start the session in 15 minutes from now. Thanks.
Okay, thank you.
Ik smos in mijn bord. Hè. All right, here we go. Hey again, welcome again. If you're joining the entire day, if you're just new to the .NET Days Online, then welcome from my side as well. I'm Martin Baljo from JetBrains, and with us we have Khalid, who will be presenting on how to start a blog. I'll let Khalid introduce the topic and himself, but before we go there, let's maybe cover a few practical things first. If you have any questions during the webinar, feel free to ask them in the questions pane of GoToWebinar. We'll try to answer the questions as we go along, but yeah, we cannot probably answer all of the questions given that there's a big audience here online. But nevertheless, I may ask some questions at the end to Khalid. Feel free to reach out to the speaker afterwards if your question was not handled. I'm pretty sure he will enjoy the fact that you can reach out on Twitter. This session and all other sessions of the .NET Days Online are being recorded, so if for any reason you have to drop off during a session, you can always check out JetBrains TV on YouTube. But of course, we appreciate if you can stick around for the actual session while it's going on. With that, let's switch to Khalid's screen and enjoy some information on how to start our own blog. Looks like we have a little bit of an issue with starting the screen share, so we'll try that again in a bit. Khalid is rejoining the session here. Meanwhile, if you're online, use the questions pane and let us know where you are from, where you are joining from, just to see where the audience of this .NET Days Online lies today. Khalid
Okay.
is rejoining. Yep, we can hear you.
Yep. I can hear you. Yeah, my GoToMeeting froze, so this is off to a great start. So.
No worries. Let's try the screen sharing again.
So you can probably see my screen, right?
Yep, all good now. Take it away.
Okay, so thanks everybody for joining. I really appreciate the opportunity to talk at this event. Everyone I've seen so far has been great, so hopefully I live up to what has come before me. So today's topic is going to be mainly around starting a blog. My name is Khalid Abuhakma, and my Twitter handle is @buhakma. It's kind of a joke, but it's up there. My job today is dev advocate. I mainly focus on .NET with Martin and other folks at JetBrains. We blog professionally at blog.jetbrains.com/.net. So check that stuff out if you're interested in Rider or ReSharper or anything .NET that folks are doing. So I really recommend that. I also blog personally on my own site. You can actually get to my blog through multiple domains. There's abuhakma.com, khalidforamerica.com, just kind of a joke since we're in a political year, khalidabuhakma.com, and some other permutations. If you haven't noticed, I have a domain problem. I could probably fund a small island nation somewhere with all the domains I've purchased. So yeah, I don't recommend it, but I have a problem. So I would say I've been blogging for about 10 years, and that's kind of a conservative estimate. It's probably been a little longer, and I've learned a few things over those 10 years. I've blogged on .NET platforms, I've blogged on other people's platforms, and today I use a static site generator, which you'll kind of see later in this talk. But I have a lot of experience with different platforms and kind of hard-learned lessons throughout the years. I want to start off by giving folks some general advice and what I like to think of as human advice. These are things that bloggers should think about when they're writing and think about, excuse me, think about these things as it relates to human beings. Later, you'll see in this talk that we'll also be getting advice around algorithms and bots. But the first set of advice I would really give everybody, and I know I showed you that I have a lot of domains, but I would really, really recommend everybody today go out and purchase a custom domain. I have a pretty unique name. If you were to Google my name, Khalid Abu Hakma, I would almost certainly always show up first in the search results. You could try that now while I'm talking. And that's kind of an advantage to me. If you have a name that's pretty common, like John Smith, it might be difficult to get that custom domain. So put some thought into purchasing a domain so that you can host your blogging platform. It's definitely the #1 thing I would recommend for everybody watching right now if they don't already have one. This is something I had to learn over a long period of time, but it's really important to remember that you as a writer are unique in the context of all ecosystems. We saw a lot of people today give talks about machine learning, syntax trees, and while there's other people doing those things, those folks bring a perspective that's unique and important to growing not just themselves, but the community. So there can be kind of some internal self-doubt when you're thinking about starting blogging and worried that the content that you're going to produce is potentially derivative of what other folks are already doing in the space. So if you're a .NET person, you might say, well, I know these other folks are better at blogging than me and I shouldn't write the same stuff. But given the entire context of the work you're doing and the place that you're at right now, it's really important to think about the value that you can add. So don't be dismissive of yourself and remember that you are really unique. From a high level standpoint, you can think about that like philosophically, but it's also important to distinguish yourself. Some things I've done to try to distinguish myself, other than obviously having a unique name, is put a little bit of effort into some branding. On the left-hand side here, you can see what essentially is a logo. It has kind of a synthwave, vaporwave style. It's something I like. I like that kind of aesthetic, and my blog kind of has that. I also take some time to create visual cards for each blog post that I end up writing. And I think that's important for me, as you'll see in a later slide, that it kind of sets you apart from other folks that are also blogging. And that adds to your uniqueness. You know, be inspired by other folks, but try to find your own voice. This is a really important point when you're starting to blog. Make sure that your content adds value. This is something I didn't really get early on when I started blogging. I was starting to write about things like, oh, I worked out today and I did 10 push-ups, or my wife and I went for a walk in the woods. And while those stories are nice and they're personal, I was treating my blog like a diary. And that doesn't really help a lot of people to know that I did something that day. When you start writing, think about what the problem is and why you're writing and how it can help solve problems for people. The interesting part about adding value as well is that ultimately you end up repeating yourself anyways, so you find your old blog posts and actually end up helping yourself. So when you're writing, just make sure that there's a point and there's a value proposition to everything that you're writing. One of the ways I like to make sure that I'm adding value is by doing a little bit of research. This is a really great technique anybody can use today. Go into your favorite search engine, type in a term that you're interested in writing about, and look at the auto-suggest. In this example, you can see that I'm using ASP.NET Core, and the suggestions are ASP.NET Core 3.1, ASP.NET Core Docs, middleware, configuration, cores. These are topics that other developers in your community are looking for and looking for answers for. This is a great opportunity for you to go to any one of those search results, look at the results, and see if you can do anything better than what's already there. Granted, right now in the .NET space, the Microsoft Docs team is doing a super great job in terms of writing content and helpful stuff. So it is becoming a little bit more competitive. But again, you're unique and you can add a lot of value to these topics that maybe the Microsoft Docs team or someone else hasn't. So keep this trick in mind when you're starting to blog. Speaking of community, it's really important to be engaged in the community that you're writing for. So as .NET advocates at JetBrains, we spend a lot of time on Twitter and social networks to kind of talk to developers. But I feel like everybody should really be doing that and understand where they fit within the community that they're a part of. I have some platforms here. Twitter is my favorite. You can reach me there at any point in time. I've also experimented with Practical Dev, which is dev.to, which is a great blogging platform if you want to start there. Reddit, and I know a lot of people are starting to experiment with video. So platforms like Twitch and YouTube are a great place to be engaged. Some techniques that I use to be engaged on Twitter is I actually have a blog promoter application. And you can see on the left-hand side, there's a little bit of a code snippet there. It just picks a random post from my RSS feed and it decides to tweet it. And you can see on the right-hand side is what that tweet looks like on Twitter. You can kind of see the effort that I put into the branding side of things really pays off when those tweets come through in someone's timeline. So again, a lot of these small tips and tricks, they can really add up to a huge impact. You can actually look at the entire code base on github.com under my blog promoter repo, but to be honest, it's one program.cs file that does everything. It's pretty straightforward. One of my favorite things that I've just adopted in the last year is writing on a schedule. This isn't something I really used to do in the past. I would just write whenever I kind of felt like it, and it kind of showed in my blogging pattern. I would write, 5 blog posts in 1 week and then nothing for months, and that wasn't really consistent. The thing I like to think about when I think about blogging is one of my favorite analogies, which is each blog post is kind of like a thimble in the rain. And what you're trying to do is catch as much water as you humanly possibly can. So the more you write and the more consistent you are, the more readers you'll potentially get. So something that I do to keep myself on schedule, I've written a for command, which you can kind of see how this is done on my blog. It's a simple command that I just say Jekyll info, and what it tells me is today's date, which is nice information to have. It tells me my latest blog post. It also tells me if I was to write another blog post, what date would that post be published on? And then I also have a backlog of days away that my post will be. So in 77 days, I'll run out of content, which, it keeps me motivated to make sure that I'm providing as much content as possible, and also not feel the stress and pressure of having to constantly produce stuff. 77 days for me is a pretty comfortable buffer. You can kind of also see the latest posts that I have in this Thor command. And again, below you can see my iCal calendar, and I just have a recurring calendar event that tells me to write a blog post. So that's super important. One of the things, I've talked about blogging on a lot of platforms, and the thing I regret the most is kind of stopping and quitting. Just getting inside my own head and realizing, like, well, maybe there's some other people doing it better, or I'm not adding anything. And every time I start back up, I regret kind of stopping that momentum. I would say make sure you don't quit and you stay consistent. I know life gets in the way, but you won't regret staying on this path once you start it. So please don't quit. The community needs you, and it's fun to read what other people are doing. So I talked a lot about human advice. That's stuff related to you. And humans have a lot to do with your readership, but sadly, bots have even more to do with your readership. They don't feel things. They don't really care about you, but they're super critical to getting humans who care about you to you. So I'm going to give you some advice that I've kind of learned over time as I structured my blog. Bots love semantics, and what I mean by semantics is make sure that your HTML is structured properly. As developers, we may sometimes want to focus on the back end side of things and maybe not understand what's happening on the front end. So we may cheat to get the styling we want by using things like H1, H2, and H3 tags incorrectly. This can have a huge detriment on your traffic because when a bot crawls your site, and when a bot crawls your site, it's looking for these header tags. H1 is basically what is the content that is on this page. And if a bot finds 20 of them on a page, well, it's going to get confused and it's not really going to think your page is valuable for really anybody. This is something I learned the hard way. I used to cram a bunch of like buzzwords into titles, and it doesn't really help as much as you think it's going to help. You may want to be as expressive as possible when writing a page title. Like parsing syntax trees for F#, using Phantasmo for Rider. Like there's a lot of content there, but the truth is when you go look at a search result, you're going to notice that Google or DuckDuckGo, they cut it off at 70 characters. So as much value as you can fit into under 70 characters, you should kind of distill your titles down to less than 70 characters if possible. This is something else that I kind of experimented with and realized it was a waste of my time. I used to experiment with things like hyper short posts, like a sentence or two and then a code block, but those barely get any traffic. I found with my content, you need to at least write 300 words. And normally I target between 700 and 1,000 words when writing any blog post. I know it can be daunting, but with a little bit of practice, most folks can definitely get there. Also, the thing you have to realize too is when Google comes to your site and finds a bunch of code samples, it can't compile or understand any of those code samples. So take the time to actually explain in human language what your code samples are doing, and that will help add additional words and additional value to your blog posts. Another thing that Google has really started putting an emphasis on is performance of your site. Things like unoptimized images, blocking JavaScript, those are going to hurt your site's ability to show up in search results. So be mindful when you're reaching for that, heavy front end framework, or you're putting 4K images and downsizing them to thumbnails. That's really going to hurt your site. This particular issue here, where we're optimizing for mobile, has become super important in the last decade. I still find a lot of developers read my site on their desktop computers, and about 75% of readers want to read on their desktop. But Google has started boosting people's sites that are optimized for mobile. What that means is optimized images and responsive design to be displayed on someone's mobile phone or tablet. So while my readership is really geared towards desktop readers, I still need to do this just so that I don't lose out in more readers. Ultimately, I know all this stuff because I'm measuring this, and Google Analytics is a great tool. I know where people are coming to my blog from around the world, what topics they're interested in, breakdown and demographic. And I think that's super important as you're on your blogging journey to understand why people are coming to read your content. So if you're watching this on YouTube, sitting on your couch, I've included a QR code. If you take a picture of this, you'll be able to get to Google's SEO starter guide, and you'll kind of see Google makes no secret of how they actually rank your site. And it's a great place to start if you're thinking about blogging. So I know a lot of people have differing levels of competency or technical experience. So I've kind of broken down 3 options that anyone can take. The first option, if you're just a complete technical novice, or you're just kind of uncomfortable managing your own blog, is just going with an online service. I actually have picked 2 online services that I would recommend, and I'll kind of break down the pros and cons later. The first one, which has kind of garnered a lot of hype, and a lot of people use it, even news outlets, is medium.com. You can go sign up for medium.com right now. This is what their UI looks like, and it's a very bare bones experience. It's really targeted for anyone who's non-technical, and you can kind of see what options they offer. You can add some basic tagging, you can share to social media outlets, and you can kind of bounce through each one. WordPress.com is another really good option. It's kind of the OG of blogging. This is their blog as a service offering. It looks really similar to Medium, and logging in, you kind of can see some of the things you can do. You can have a header, you can create basic bulleted points, links, you can put tags, you can upload and set featured images over here. So it's really similar, and it's a bare bones experience, and you can get started blogging today. The real pros of these platforms are they're free. They're free-ish, I should say. They're managed for us. Being managed for us is good because we don't have to think about that database upgrade or that security vulnerability, and we also don't have to pay out any money for that. The other thing I like about these platforms too is there's a community cross promotion that occurs that maybe can't occur if you are hosting your own platform, which that can drive more readers to your blog. So these platforms are great to kind of grow your audience very quickly on the back of other people's work. So here are some cons with these platforms and maybe why I wouldn't recommend you look at them. There are upsells all the time. These companies have to make money. That's how businesses work. They need money to keep themselves afloat. So what they're going to do is they're going to target you with ads constantly, and that can get really, really annoying. I know it was annoying for me when I logged into WordPress.com. They were constantly trying to sell me domains and themes, and it was just kind of distracting overall. This next one I don't like personally, just from looking at the stuff that I've done with my own personal branding. These things can kind of be bland. WordPress.com has a lot of themes, but Medium has adopted this kind of flat design aesthetic. And it's actually kind of been interesting to watch Medium struggle with their flat design. News outlets that have journalistic integrity, vetting processes, they look exactly the same as some crazy crackpot person in their basement. And that kind of hurts everybody who ends up blogging in those communities. Which kind of brings me to my next con, which is community noise. At the end of your blog posts, you may be promoting, or it may look like you're promoting something that you would never promote, and that can kind of hurt you as well. Ultimately, these are for-profit companies, so when you're investing in their platform, you're adding value for them in the hopes that you get value. And if they decide to change their mind, you can kind of be at their mercy. So this is a good place for people to start, but I would definitely try to steer you away from some of these services. So let's say you've been blogging for a little bit, you're getting really, really confident, you're growing your readership. This is probably where these next two options are probably where I would focus most people. And it would be like a self-managed platform. One of the popular ones out there is Ghost. It's written on Node.js. And you can kind of see how the UI looks, and they have a mobile app, which is kind of great. And it looks very similar to what Medium and WordPress.com offered. The nice thing about Ghost too is it has some social capacity. So you can see on the left-hand side, there's members and staff. So you can kind of work together as a team to build a blogging outlet. Another option, not to be confused with WordPress.com, is WordPress.org. It's a self-hosted platform. It runs on PHP, and Ghost actually got a lot of inspiration from WordPress. You can kind of see it offers posts, pages. There's also a lot of custom themes, so you don't have to look like everybody else. And there's a lot of plugins for WordPress. The nice thing about these self-managed platforms is you own it. You own the whole thing from the front end, from your posts, custom domain. It's something that is yours and no one can kind of take away from you, which is really nice. They also come with really strong WYSIWYG editors. If you're not familiar with that, it's what you see is what you get editors. So if you like writing in Microsoft Word, these are going to be right up your alley. They also come with a lot of plugins. I showed you how I do my Twitter promotion, but these platforms have plugins to do things like automatic tweeting and RSS feeds and publishing on schedules. So they're really nice. And being that they're popular, they have a lot of community support. So you're never going to feel like you're out in left field by yourself trying to maintain these platforms. With popularity comes risks. A lot of these platforms are hacker targets. WordPress is definitely the most popular blogging platform, easily by a mile on the planet. Like it's the thing most places run. And due to that, they can really become targets for hackers. So you kind of have to make sure you stay up on security updates and issues like that. They can also be slow. They obviously talk to a database on the back end, and that can add latency to your site, which again, if you remember back earlier, performance is a really huge indicator in terms of whether these search engines determine your value as a blog. And at the end of the day, they can kind of feel like pets to me, constantly managing security updates, databases, paying for hosting. That stuff just kind of gets in the way of writing for me. And it's not fun after a while when you maybe log in and you see there's like 100 security updates you need to install. Needing to run all this stuff with a backend database too, that's just going to cost you money. I think on DigitalOcean, it costs about $5 a month to run just a bare bones site. And I would recommend that. But again, that's $5. And right now I basically pay nothing to host my site. So we're up to kind of the advanced topic at this point. And this is kind of what I would focus most people on. This is how I blog. And I can kind of show you at the end of this talk, like how my blog actually runs on my machine. But since I'm talking to a technical audience right now, this is where I would steer everybody on this talk to at least try. And if you don't like it, try the intermediate level. The thing I would recommend most people start off with a static site generator is just use GitHub Pages. It works really great, and I'm about to show you 5 steps to just get started without even playing with the command line or doing anything like that. So the first step is to create a repository, preferably your username if you have a GitHub account, .github.io. What that does is GitHub offers everyone GitHub pages at their at this particular URL, and if you name a repository like that, that will be kind of your domain. The first step is to create a _config.yaml file. I've picked this Minima theme, which is really great. I've seen a lot of people use this theme and it works really well for those folks, and I would recommend it. So first step, right in the GitHub UI, just go ahead and create an _config.yaml file and put this one-liner. By the way, if you want to see this live, you can go to my repo here. It's published right there. The next step is to add an index.md file at the root of your repo. And we just want to create just this content here. We're going to set the layout to home. Just making sure. Yep. The fourth step is to create a directory of _posts. and we're going to create our first hello world post. And using Markdown, we can just put these 2 lines in it. The first one is a header, and if you're not familiar with Markdown, using the hash basically says this is an H1. You can actually add multiple hashes and it'll go down the list of header tags of H1, H2, H3. And then the content is just, you know, plain text, which is great. This step is probably not necessary if you named your repo the right way, but I like to just check my GitHub settings just to make sure that the URL is done correctly. You should see your site is published at the top, and then you can kind of go to it. And if you followed this exactly, which there really wasn't a lot of steps, you should have your own blog up and running. So hopefully everyone listening today at least does this and they can start blogging today. That's kind of cool. So I'm a big fan of static site generators. What you just saw and what GitHub Pages supports is Jekyll. That's what I use for my blog. If you've gone to abuhakma.com, everything is generated at build time. And there's a lot of advantages to this, which I'll get to later, but I just love this format of blogging. It's really clean and simple. There's a lot of options out there for static site generators. I personally like Jekyll just because of its stability and maturity. It's been around forever. I also love 11t. 11t is based on JavaScript, and it's doing really great right now in the community. It's something I'd highly recommend if you're a JavaScript fan. Hugo is another static site generator. It's blazing fast. It's kind of crazy how fast it is. It's written in Go, and it can compile thousands of pages in like under a second. It's crazy. Sometimes I don't even think it's running right, but it is. It's doing its thing. And you can basically find a flavor of static site generator that works for you. On here I have static, which is written in C#. So if you want to stay in the .NET realm, it's definitely something I'd recommend. Like I said, I've been using Jekyll. I love it. It's pretty awesome. And you can kind of see what other people have done with Jekyll. There's a lot of GitHub repos out there. And you can fork those blogs and kind of see how they work under the covers. A lot of these static site generators also work off of Markdown. So if you're familiar with Markdown, it's pretty straightforward. I'll have a link to where you can learn about Markdown, but there's really 2 parts to most of these static site generator pages. There's the front matter, which is metadata. It sits on top of your content. And then there's the actual content of your blog post. In this example, you can see the front matter at the top of the page. It sets the layout, the title, subtitle, date, and permalink. And then the content is below. So the heart of every static site generator is just Markdown. And I think that's the thing I really love about them, and that's why I'd recommend them to any developer, because at the end of the day, it can just kind of help you focus on writing. Here's how I build my blog, and I can actually drop into the command line later to show you how it runs on my machine through command line. But basically, I just run a command, and within 6 seconds, my entire blog is built. I also pass in a future tag just so I can see those backlog of blog posts as I'm writing for the future. Excuse me. And the nice thing about a lot of these static site generators is they come with their own internal servers. So you can run all this stuff locally And unlike a self-managed platform, you don't have to set up a database. You don't have to figure out permissions. You don't have to create a user local name or a local username. And you don't have to keep those synced with your production instance, which is kind of really nice for me. So this is pretty easy, right? You just write a bunch of Markdown, you build it, and then you deploy it. Not everything in life's really that easy. It's easy once you get the hang of it, but there is a lot of upfront stuff that you have to do with static site generators, and it can kind of be daunting at times. You have to figure out how tagging works. I'll be honest, the way tags work on my blog and pagination works on my blog, it's kind of annoying sometimes because there's no structure. The looseness of Markdown sometimes makes that difficult. Dates, multiple authors, dealing with the semantics of Open Graph so you can get those fancy Twitter card images. All this stuff kind of starts to get overwhelming and daunting. So, but honestly, don't be discouraged. I really want you to look at a static site generator. The first thing I'd recommend anybody do when they're looking at starting a blog, buy a professional theme. This is a site, I'm not really affiliated with it, but I'm really impressed with their themes. And for $50, they've thought of most of everything for you. So paging, SEO, all the stuff you want, you can just kind of get started, and their themes look pretty great. So I would definitely check them out. And think about it, most of you are professionals. $50 versus hours and hours and hours of time spent fiddling, it's a deal. So I definitely recommend that. So what are the pros of a static site generator? For me personally, it's about full control. When you're thinking about a self-managed platform, you kind of have to figure out what their programming model is. WordPress is very difficult sometimes, especially someone who doesn't do PHP. And these static site generators deal a lot with static files, so it's very easy to see how it all kind of comes together. So full control is really awesome with these things. You know, I talked a lot about focus and writing and how I love Markdown because of that. And I can't overstate it enough. Like when you're blogging, you want to focus on writing. And a lot of these other platforms that are kind of PHP or node based, you can lose focus when you're in a WYSIWYG editor. Should this line be highlighted? Should I make this word bigger? Should I put the images on the left or the right? And that can kind of detract from your momentum. The nice thing too about static site generators is they're very flexible. So writing in HTML, CSS, and JavaScript, you can kind of basically do anything. So I love it for that. And as developers, I think everybody wants, you know, a few options there. One of the things I don't like about static site generators is they can definitely be fiddly. I love 11T. I would recommend it to everybody. And there's a lot of extension points, but you can kind of get lost kind of tuning your car rather than driving it. And I think a lot of these static site generators can kind of get lost in that. Again, you want to focus on writing. You don't want to spend all your time building this supercar and never actually getting to drive it. And I think static site generators can sometimes be that kind of trap. Which, again, makes you lose focus from the reason you started a blog, which is to write. So keep that in mind when you pick these platforms. You want to write stuff. You don't want to keep fiddling with it. This last one probably isn't a problem for most people, but as you start to add more content and more pages, your build time can increase, and that can kind of ruin your feedback loop. I don't want you to be discouraged. I know I had a few cons there, but I still would really recommend you look at a static site generator. There's a lot of cool things you can do. One of my favorite things is, being that they're mostly static files, we can cache, and we can cache really hard. What that means is we can push our content into CDNs. We could even cache most of our content on the user's device, so that you can get things like offline mode. You can serve people directly from their country. So I host my blog on Netlify, and they push to their CDN, which means folks in Japan, folks in Europe, they get the same exact experience reading my blog that someone in the United States would, which is a huge benefit to me. Whereas if I was to host my blog in the Eastern US, only people in the United States would get the best experience reading my blog. Whereas, folks in Japan or folks in Europe, they'd get a degraded experience because, yeah, my hosting is in the United States. The other thing about static sites is it's basically cheap or free. I mentioned I host on Netlify. There's other static site options out there for hosting static sites, and they're basically free. What a lot of these companies are trying to do is upsell you on, APIs and functions to increase the capability of your site. But if you're just writing a blog, they'll basically give you static hosting for free. I can't understate how awesome Markdown is. You may not really get it until you start writing and you realize you kind of crank out a lot of content, and that's really cool. And Markdown has changed my relationship with writing completely. I think it's the most transformative technology in the last 20 years, at least for me. So I've kind of gone through all the options you could have to starting a blog, from baby steps to intermediate to advanced, using static site generators. But it really comes down to engaging with humans and engaging with the community. Remember that you're not just working or writing within a bubble. There's a whole community that you're hoping to impact and to help. As much as humans are the folks you're trying to reach, you kind of also have to think about robots. They're kind of a necessary evil when it comes to the internet. Not that they're evil, I mean, they're robots, but they're really going to be what drives traffic to your blog. Most of my blog traffic, maybe 90% of it, actually comes from organic searches. So you really have to think about them. The other reason that I'm really pushing static site generators, and you should really think about this, is you want to help yourself and you want to help your community. And that means taking ownership in the content that you create. While I like Medium and I like WordPress.com as technical options, when you write on those platforms, you are investing in their value and hoping to get value for yourself. Whereas when you buy a custom domain and you host it yourself, that is your value. So really think about taking ownership. And finally, I would just say just do it. I know the internet is kind of a scary place sometimes. I've gotten my fair share of comments and you're doing this wrong, and those kind of hurt sometimes. But I've also gotten emails from folks thanking me for writing a blog post that saved them weeks. And that makes me feel great too. And when you get those kind of comments, it's really motivating. So I would just really, really recommend you do it. So I also want to offer, you can reach me on Twitter. This is a QR code. Again, if you're sitting on your couch, just take a picture and it should come right up. You can also read a lot of the technical ideas and how they're kind of spelled out on my blog. So if you go there, you can kind of see the mechanics of it. I also have office hours, and I'd love to talk to anybody who wants to start their blogging journey. So you can actually go to my blog. There, you should see an office hours at the top, and you can schedule time to sit with me. I don't charge, not yet, I don't think. I'm not sure I ever will, but if you just want 30 minutes, I'm glad to talk to you. So with that, again, thanks to JetBrains and thanks to everybody. Thank you.
Thanks, Khalid, for a very inspiring session. As one of the audience members said, it's time to wipe the cobwebs off of my blog and get to it again. So you've inspired some people, which is always great.
Cool.
There are a couple of questions, though. A couple of philosophical ones and a couple of process ones on how you write. So what do you want first?
Surprise me, I guess I should say.
All right. What do you feel is in it for you? What is the main reason for starting and writing a blog for you? Why not just be on Twitter?
I guess for me, it's nice to have a long form idea. The issue I have with Twitter is I love communicating with people, but it's very ethereal. If you put your answers and you put your value into Twitter, kind of like I mentioned at the end, that kind of just evaporates immediately. What I get out of blogging too is folks I really admire. Maybe this is for you, Martin. I know I've said this to you personally, but I really admire your blog, and there's a lot of people in the .NET space I admire, and I'm really happy that they blog because it really pushes me. And if I can do that for just one other person, that's great. But now I work with Martin, which is awesome. He's one of my .NET heroes, and I get to work with him. So I kind of got that out of blogging. So that's a plus. You can stop crying. You can stop crying now, Martin. Yeah, I know.
All right, couple of practical things. You have that writing schedule in your calendar. Does that actually help you motivate to write things? What do you do if you have so-called writer's block, even though your agenda says you have to write something?
Well, it's funny. I found that writing even things that you take for granted are really, really good blog posts. Like, those are the ones that are gonna take off. Whereas I could spend a week trying to create this elaborate tech demo, and I don't get nearly as many readers as just describing how equality works in C#. So how do you get over writer's block? Just don't take any of your knowledge for granted. You might think, oh, well, everybody knows this, but it's really something you can elaborate on and just do a little differently. So I do get writer's block, and scheduling out, it's a motivator, but I think the backlog helped me feel like I'm not pressured into writing. Like this week, I wrote a companion blog on this talk that you can kind of go read and get specific details. So if I can stay within 2 to 3 blog posts a week, I feel pretty good. If I drop down to 1, I still feel pretty good. So there's a lot of ways to combat the pressure, I guess. Hopefully that answers that person's question.
I would guess it does. Let's switch back to a more technical slash practical one, which would be we're talking about social, Twitter, blogs, and so on. But then we're also talking about static site generators. Those typically don't allow comments on a blog post. How do you handle those? What do you think about comments? How do you handle all that?
Yeah, I currently use Discuss, Disqus. I think that's how you spell Discuss. I felt like a cheerleader there for a second, but I use Discuss for commenting. The nature of static sites is you're going to have to use APIs. I'm not sure if folks have heard of Jamstack. I know Jamstack is kind of a buzzword lately. Jamstack stands for JavaScript APIs and Markup. And the APIs are an important part of bringing dynamic feeling elements into your page. So Discuss is one of those. In terms of comments, I like folks leaving comments, but it's a performance killer. I've actually started lazy loading my comments just because they can really drastically change the loading time of your pages. And again, it hurts your traffic. So if you don't feel there's a lot of value in comments, I would just say leave them off, but I like interacting with people. Yeah.
All right, thanks. Then maybe one final question. What is for you the typical time investment for writing a blog post? How many hours a week do you spend? And how does that break down into trying out something, writing a code sample, and actually doing the writing?
That's a very loaded question, just due to the fact that it depends, right? I hate to answer
Have
with
you
it
been a
depends.
consultant?
I mean, I guess I could hire a writing staff. That would make things easier, but that would defeat the purpose of having my own unique voice. No, but in all seriousness, it takes time in terms of what you want to write about. If you're writing about something that's already researched, like you're using Microsoft Docs as kind of a way to elaborate on stuff, those kind of blog posts don't take that long. I would say maybe a couple hours. If you get good at it, you could probably even get faster. I recommend tools like Grammarly because they can kind of give you a second set of eyes when you're writing and help you kind of catch problems before you have to go back and reread everything. So that can cut down on a lot of time. But again, if you're doing something super complicated, like I wrote a Xamarin post for JetBrains, and that took a little bit of time because I've never really done Xamarin stuff before. So it depends.
All right. I guess that's a fine conclusion. It depends. With that, let's switch back to my screen. I want to thank you again for a very interesting session. And I think at least a couple of people are inspired to start blogging or start blogging again. So that's always good. We'll be back in about half an hour with Ricardo Terrell on building a highly performant inter-service communication with gRPC and ASP.NET Core. We'll see you there. And yeah, hope to see you there. Hey, Ricardo.
Hello, how are you?
Good, good. How are you?
Good.
For the people in the stream, you'll probably be seeing Ricardo right now, and I'll show myself as well. We're going to do a very quick tech check and make sure that screen sharing and audio works. Well, audio already works, obviously, but let's see if screen sharing works as well.
Okay, can you see it?
I can see it, yes.
All right, cool. And
For
you only start the PowerPoint, and I think we're good to go. Mr.
yeah,
PowerPoint.
perfect. For
All right,
code, I guess you'll have to zoom in a little bit. PowerPoint looks fine.
PowerPoint, yeah. Yeah, the code, I have the, let me see. I usually then is to zoom in like this. It's good.
Yep.
All right. Yeah, I tried to center here, and I have a couple console I'm gonna run here, but I think that it's going to be fine.
All right, perfect. Then we'll put ourselves on offline for 15 more minutes, and then we'll kick it off.
All right, excited. Thank you for having me.
Yep, thanks for joining. Very much looking forward.
All right.
All right, here we go. Hey everyone, I'm Martin from JetBrains, and welcome again to this last session of the first day of JetBrains.net Days Online. With us, we have Ricardo Terrell, who will be talking about gRPC in ASP.NET Core and building highly performant inter-service communication using that. It's quite a long title, so I'll let Ricardo introduce the topic himself. But before we go there, let's cover a couple of practical things first. First of all, if you have any questions, feel free to ask them in the GoToWebinar questions pane. We'll try to answer questions as we go along, either by text or by asking Ricardo at the end of the session. Do note that we may not be able to answer every single question because there's lots of people online, but we'll still try our best. This session and all other sessions will be recorded, so if you have to drop out at some point or you missed a session and you still want to see it, we'll put them on our JetBrains TV channel on YouTube in the coming days, probably somewhere next week. But of course, if you can stick around, we appreciate you sticking around and joining us for the actual live session. With that, let's switch to Ricardo's screen and let's kick off this gRPC and ASP.NET Core session.
All right. Hello, everyone. Let's see. Well, thank you for the introduction, and thank you for having me in this beautiful event. Can you see my screen?
Yep, all good.
All right, cool. Just double checking. That's great. So, well, my name is Ricardo Terrell, and I'm broadcasting here from Charlotte, North Carolina. You mentioned the title is quite long, right? Build a performant and polyglot inter-service communication with gRPC, and of course in .NET Core. Long title, but really boiled down to the fact that gRPC is a tool that can be used for real cross-platform communication when performance are the key component. And for those of you that don't know me, I'm a big performance junkie, and gRPC, I really fall in love with gRPC. What is also interesting, it really integrate quite well with .NET Core and other programming languages, but particularly with .NET Core, starting with .NET Core 3.0, Microsoft decided to integrate gRPC in a part of the framework, which is quite convenient. The main key, as I mentioned, is a fast cross-platform platform for high-performance communication, and really aim to mitigate the issues of the communication when we are in a microservice architecture or distributed communication, any sort of communication service to service. gRPC really making much easier to solve this kind of pitfalls. One thing that I will demo also later is great support built in for streaming communication and bi-directional streaming communication client to server, and also integrate quite well with ASP.NET Core. Now, one thing that I believe the Microsoft decided to integrate gRPC part of the framework is that .NET Core no longer have the support for the full framework, right? Which it make like the end of support for the WCF in the future, right? I'm not going to talk about WCF in this presentation, but if you have some project that use WCF and you are considered to migrate to .NET Core, definitely gRPC represent a valid migration alternative. So there are many ways in which two or more microservices can communicate over the network, right? In history, like one upon a time, we have like back in the 70s, RPC as a remote procedural call, one of the solutions, queuing and so forth. And later, most recently, we have, from XML over HTTP to SOAP, and then we move to JSON over HTTP to REST. And REST, it is de facto the way we today model the API. For example, when we have to build like an application or a web application, we get some design, some requirement, and we start to build applications. So we could have something like a server, the process, and expose some API through HTTP. And then we can have a client or multiple clients that consume this API. And further, we can have more complex scenario where actually the server itself have to communicate with external services, and everything looks quite familiar. And we can host the application as a monolithic application. Like we can host all this application on one server that most likely can run in one process. In this kind of scenario, we use REST, which is perfectly fine. In general, REST is fine in many cases. And so REST is really a client-server relation where backend data is made available via simple representational state like JSON to the client. And REST protocol really does not enforce, however, the rules about how it should be implemented, at the lower level, but rather provides guidelines for an higher level architecture implementation. But really, overall, REST is fundamentally based on communication of JSON over HTTP. So we're building an API where we use JSON as the payload, and then the request or response to communicate between services or client and service. And then we have in the HTTP verbs such as get, put, post for the call between endpoints. So this is great, but these days we're something, we build application in a different way. Today, we like to build application, in a more complex system. We pass from that kind of architecture, from monolithic, multi-tier, and so forth, architecture. And then we have these days something, that more trendy, such as microservice architecture or distributed computing. And the microservice architecture style, has been really, it's taking the industry software by storm in the recent years with the promise to deliver a resilient and scalable system. And of course, these days, it can be easily Dockerized, right? So in a nutshell, microservice architecture aim to break up, the single classic monolithic software into a new, into several, into a number of independent and distributed components, in which each component run in its own process and perhaps communication with others. And this is really the trend architecture these days. But with that, introduce also more complexity, some challenges, especially from the communication point of view, where we might have to communicate between services that are, different machine, different processor, and perhaps use different platform, or maybe they be implemented using different programming languages. So, in addition, there are some challenges. So how can we guarantee, for example, that the API are compatible over time with the evolution of each service, right? How can we handle the communication between, service one to service two, and possibly, in a synchronous fashion to be scalable, responsive, and keep those components decoupled and compatible? Well, let's bring it to gRPC, right? So what is gRPC? gRPC is a framework, an open source framework designed for scenario where communication efficiency is critical, and it also can target and run in many different environments. So one key is that gRPC is contract-based, right? Which use this contract is used to generate the service, the client, and the message type code for every major computer programming languages. And so the contract-based approach, initially when I start to familiarize with gRPC, I was not really keen about the idea to have contract-based framework, probably because back in the day it was burned by other frameworks. However, it really does make sense in a microservice architecture because gRPC allows us to generate clients and services that know and they were able to communicate with the right shapes and use the call as expected, right, that they need. So let's take, for example, ASP.NET application that consumes some API exposed by third-party service. Well, that service potentially could evolve independently with no guarantee that the HTTP API will evolve in the same way. So how we can preserve the backward, compatibility? It really become a challenge. Therefore, the link between the API owner and the caller, had to remain quite loose. So this is one of the scenarios where gRPC can help by keeping different services communication compatible and be able to interop over time. So the key component of gRPC performance, right, is gRPC used as a smaller and faster binary protocol for the communication called protobuf. And we're going to talk about protobuf coming shortly. And the gRPC is also leverage the HTTP2 feature, and which support multiplexing requests over a single connection, which enable responses to be sent soon as they're ready, without to put in a queue and then some sort of delay and extra overhead. Interop, I mentioned fully closed platform. gRPC is not just a framework, but provide a set of tools and library for all major programming languages, including .NET, but Java, Node.js, Python, of course, Go. Streaming is support natively part of the framework, and gRPC have full bidirectional support full bidirectional streaming communication that can operate over intercommunication, can go across load balancer and service clusters. Timeout and cancellation. This is actually very cool. Cancellation can be propagated through the gRPC calls from service to service, but also from client to service, to help not just to stop an execution, but also to enforcing some limit of resource consumption. And client may also abort or cancel an operation on the server side using just a cancellation token. So really, it really allows us client to specify how long they're willing to wait for an gRPC call to complete, and then have a timeout or a cancellation token that is propagate and stop the process. That actually work quite nicely. We have a demo for that. So this is a huge plus coming from a traditional, REST API, where the cancellation support client to server is not that easy to implement, right? It's not built in. You can implement it, but it's just very painful and it's no fun. And security is also integrated part of the framework, because gRPC is implicitly secure as default, because use HTTP2 over TLS for end-to-end communication, where the connection is fully encrypted as default. So gRPC, RPC as a remote procedural call is nothing really new, right? But the way that we communicate between services today allows us to review and reconsider back this protocol as a potential good solution. So RPC, in a nutshell, is a call to a function that run on a remote server. Basically, we deal with a local function that the same signature contract of a remote function. So we're calling the function locally, but actually transparently, we are passing the argument, it's any, to a function that is executed on a remote server. So for the past 15 years, Google has worked with using this protocol and evolved this model internally with a project that was called initially Stubby, which is an RFPC framework that consists on a core component layer that can handle, internet scale of 10 of billions, no million, billions with a B, or requests per second. So the framework has been then open sourced back in 2015 under the name of gRPC, where apparently the G has nothing to do with Google. It's just G as gRPC. So gRPC, as part of the payload, used this binary format rather than JSON as in REST. And this binary format is called protobuf, which also was implemented by Google, as had the main goal to be light and high performant. So there are several challenges, as mentioned, when we use a microservice architecture. For example, we have the need to take into account when implementing a new system from transforming that system from a monolithic architecture to microservice architecture. But gRPC gives us all a very rich set of tools and capabilities to fight these issues without having to implement your own framework. The best part, in fact, of gRPC is that it's not just a library, but really provides this rich ecosystem as well. And all end up to create your proto file, that is the file definition as the contract, and then use the proto file with the tooling to do a code gen for the client, the server, and all different kinds of programming languages. It really makes allowing these RPC framework and to build services that use a single API, no matter what language they're written. All right, let's take us to protobuf. So gRPC used a protobuf and the protocol buffer as an interface definition for a language for serialization and communication instead of text-based like JSON, XML. And protocol buffer can describe the structure of the data, and the code then can be generated from this description for creating and parsing a stream of bytes that represent then the underlying data structure that you predefine. So protobuf is really a language that is a platform and language agnostic, right? It's just a mechanism, a neutral mechanism for serializing in a very fast way structure that produce a very small binary footprint that is sent over the network, which make RPC call very, very fast. So the goal of protobuf is to be very fast for network communication, but also for serialization and deserialization of your data structure. And this is possible because the type are predefined. They are known. So because you use data structure, then thanks to the concept-based approach, the types during the serialization can be inferred directly and can be incredibly fast. So this is an example of a protobuf, and this is like an example of proto file, which represent our schema, our contract, and then we can use this file here with some command line tooling, but you can just also reference to your project and enable the compilation type, the build option to protobuf, which is an option that you become available in the project whenever you have installed and referenced the gRPC tooling. Here the protobuf, the proto file here has a different kind of section. We have the top one where we define the syntax type. In this case is the proto tree, which is the latest version of your of the protobuf language definition. Then we have the section where we define the namespace. This is optional, but become very handy when you use programming languages like C#, that we can reference then the code gen using this the namespace here defined in this file. And in this section also we can import other packages, can be other protofile and can be Google protofile packages. That in this case we import the timestamp proto, which is a Google protobuf that allows us to sort of interop between .NET, datetime, timestamp with the type the protobuf is able to understand. Then we have the service definition, and this is the series of methods that our service is going to expose, and the code gen is going to implement it. In this case, we just define the name of the function and either both the input and output of this function. In this case, the stock request, the input, and the stock data as output. And then ultimately we define the message type, right? Where protobuf is ordinal based, which means that the order the field in our messages are very important. In this case, we define our message with the message keyword and then the list of fields that are just key value pair, where we define the type. In this case, the first one is a string name symbol with, of course, ordinal 1, and then we have a timestamp name date or ordinal 2. And this is the input, and then we have the stock data, which is the output here. So when you define your protofile, then you reference to your project. In this case, this is a project file of the NSP SP file. And what is recommended that I do is recommended is have your separate folder external for your project, part of your solution, especially if multiple projects, this become very handy. And so you had the proto file defined this folder, then again can be linked to all the projects that they use this proto file. So you have only one single spot where you do all the changes, and the changes then propagate to all the projects that link this file. So the project file, we have the protobuf section here, the item group, which include the proto file, and then we have the service gRPC service definition. And this is now the gRPC tooling. What kind of generation do we want? In this case, the server, as you can imagine, the code gen is going to target only the service side, the client option, only the client side, and the both, well, you're going to produce the code gen for both the client and the server. As I mentioned earlier, when we talk about how import other protobuf module or file, is that the reason is because natively protobuf does not support all the .NET types, or perhaps all the types of all the programming languages that gRPC support. However, so for example here, there are a few like the .NET datetime and the decimal are not supported natively. However, it's possible to create a message definition to represent like the decimal, for example, type. They'll work, for the serialization in a safe manner between .NET client server. However, a better approach, as we did, is that gRPC provide a series of extensions, right? So we can specify some gRPC extension called well-known types, which is a set of external module that gRPC provide that you can use for your favorite programming languages, the idea is that provide and facilitate the code generation and runtime support for complex field and complex type like this. So how are we going to start using gRPC? Well, Microsoft collaborate quite extensively with Google to make it easier to integrate gRPC in .NET Core project like ASP.NET Core, for example. This screenshot is Rider, for example, which is my favorite IDE, and there are already available template to start creating gRPC project, of course, with the constraint to use .NET Core. when you create your service, the gRPC service, the data structure become quite familiar. If this is this structure represent like very similar to an SP data project structure. The only difference is that the project reference the underlying gRPC libraries and toolings, but is also this folder with the protos which contain all the proto files. So where gRPC belong, right? Where should it stay in our architecture? Well, first of all, gRPC support is built on top HTTP2, which currently is a limitation. So if you need something like for client and browser communication, probably gRPC is not the right tool now. There is currently in progress a work for a gRPC sort of JavaScript library, but it's not ready yet. So in general, gRPC really stands between your microservices or communication between client as desktop console application to your service, but the front end it only is the connection connect the microservices to sort of like a API gateway to your microservice cluster using your planned HTTP API, and I have a good example for this. So let's demo. So the demo I'm going to run is stock market history ticker that generates some stock ready from a local CSV file, and then the gRPC server read this data and then dispatch this data to the gRPC client that can use either a response request or streaming communication. And then ultimately later, I'm gonna demo also the web app using WebSocket and SignalR. One slide before the demo, one gotcha that I learned in a hard time. If you're working in .NET Core on a macOS, as I do, you might run into some problem when you run gRPC. You're gonna get an error, something like that HTTP2 and TLS is not supported or is not working. And this happened because currently at the moment, Kestrel does not support HTTP2 with TLS on macOS. But there are two simple solution here. On the server side, you just define that the HTTP2 is going to be communicated using HTTP, not HTTPS. And the client side is going to switch the context to an encrypted HTTP2 support. Of course, this is going to be only for your development time on your machine. In production, this is going to be removed. All right, so demo time. Let's go to my project here. So first of all, we have the ticket generation, which is a service that what it does is read from a local file system, the stock ticker CSV file. The folder is in data tickers. There are different kind of CSV file. By the end of the presentation, I'm going to provide the link that you can download all the source code so you can play yourself. So the service here read from the CSV file and expose a series of API. For example, they retrieve stock history, take a ticker as input, transform that in a series of stock data and send the response back to the caller. And we have both single call response, and then we also streaming supporting for the stream demo. In this case, return in a asynchronous numerable to read the stock data as a stream. When I read the stream here, we have the CSV stock stream class. We take a file info in a constructor, then read all the data from the CSV file, parse it, and create a collection of stock using this function parse here. It's all asynchronous, no blocking, but this is just boilerplate. This is just to let you know this is the service that produced the data, okay? And we have the stock is this shape here, the symbol, the date, and then we have the price of the stock, the highest, the lowest, the open, the close. So this is the service, and then we have the stock ticker service, and then now we have the service. So I'm going to show first the traditional REST approach, and then we're going to see the gRPC version to compare the two. So the traditional REST server is I use dependency injection to create a singleton instance of the stock service that I just show for the stock ticker generation. And then we have the API controller. I grab the stock service instance, and then here I have two API, okay? One is an API that take a symbol as input in a request, then call the stock service to retrieve all the stocks and then send it back as a huge payload. Now, for demo purpose, I only retrieve the first 50, but you get the idea here. It can be a very large number of items. On the other side, another solution that in REST is quite popular is actually a sort of pagination approach, where we have multiple calls that it passes also an offset. So in this case, we can paginate and return part of the response, only a portion of your data. So this is helpful when you want to reduce the size of your payload. However, on the other side, this has become a little bit of limitation because you have a lot of calls and requests become very chatty. So let's run the server here. Okay, the server is running. Okay, .NET run the client. The client, while it's running here, is a console app that I
Ricardo, can I quickly interrupt? I can
Yes.
maybe zoom in a little bit more in the editor.
Bigger?
Yep.
Okay.
Awesome. Thank you.
Sure. So on the client side, we have the we create the HTTP client that target the endpoint or our server, which is 5000. And then we have a simple while loop here where I can insert the name of the tickers that I want to get the history. And in this case, for demo purpose, I grab all the history of the specific symbol. But if I ask for Microsoft ticker, just in this case, I'm going to call the other API. So you will see how we're going to get different requests and different response with the offset approach. When the response is coming back, I get the stream from the response, deserialize it in our stock model, which contains the collection of stocks, and just print in our console here. Okay, this is now running. I got it probably before, so let's run this way. All right, so this is the client running. Let's call Facebook, for example, and then we got all in one transaction or our Facebook information here. Let's run. Let's rerun it. So we got Facebook. Let's go Apple, and you can see all in one transaction. And then if we call Microsoft instead, you can see there are different kinds of requests, and then each request is going to fetch back an offset incremental. This is a different pattern. All right, so that's the traditional REST. So let's see this implementation using gRPC. So first of all, we have the gRPC service, which is down here. So the structure of the code, first of all, I have to define in the startup of my web app that I want to add gRPC. Okay, I can pass some option. This is arbitrary. In this case, I only enable some error details. So during the debugging tile, if something happened, I have a better error information. But this is just good for development time. I can pass other options such as compression, the message size, and so forth. This is during the configuration service. Below, on the configuration, I have to specify that my gRPC service type, in this case, the stock market service. This is because gRPC service are not really like web API that expose the API, but expose the service itself. So after I've done this, that's really much what I have to do. So let's check the service. So the service, the gRPC service I use dependency injection to retrieve the stock service for the stock ticker. And then I override a series of methods, the get stock history. But where does override come from? How can change this? Well, if you notice here, the stock market service actually inherits from a stock market service base class. And this is actually the base class that if I have 12 over, this is a bunch of code gen that gRPC generated for me based on a contra base from my proto file. Okay, so this is all code gen for me. So then in my service, I just reference the service stock market service base class here, and then override the method. The proto file that has been used to generate this class here, the solution is inside the folder called protos, and there is a stock of proto file, which defines the namespace, the reference, and this is the method that I define in my stock market service, okay, with the messages defined here below. So each of these methods then is defined on my service here. So if I just search, here it is, this is the get stock method. And it generates for me all the method with the stock request and server call context. If it was streaming, I have part of the construct, I have access the streaming request and the iServer stream writer, but I'm going to check this in a second. So this is my service. So I suppose this series of methods that then call the underlying stock ticker service and return the result as using the protobuf message defined. So let's run this service here, .NET run. The DN is an alias that I use on my local machine for .NET. Okay, so that's now my service up and running, and I won't touch it anymore. So let's call the gRPC service, so the client. The client is defined in this case as a simple console app. Later, I have a web app that functions as a client. So first of all, as I said, I switch the context to be able to run this code on Mac. I create a gRPC channel. In this case, the channel target the endpoint of my service that now is up and running. I create an instance of my gRPC client passing the channels in the construct. And the stock market service client is also one of the code gen that gRPC generated for me. If I have 12, this is a bunch of code here that generated for me, but I don't want to waste time here. So now I have the client, which is my gRPC client service. And then I run this method here, which is again a while loop that I'm going to pass as input my ticker, send a request to retrieve all the stock history of this symbol here. Okay, and then I'm going to print in a console. So this is a first demo. So let's close the rest here. .NET run here. Okay, so Facebook, FB, they're gonna call. You can see some login here that I get a request to my service, and here I get all the Facebook return on my client. I'm gonna go Microsoft, another one, different symbol, different color, and I get all my data back, right? So this is great, but here we have also the limitation we saw earlier about what are the options when we have to retrieve a bunch of data, right? And we're gonna check streaming in a second. But first, I want to show you another cool demo that I have the service up and running. The service is in C#, but now I want to call my service using, for example, a Python client. So I have a project here, my gRPC Python client. So Python is one of the language supported from gRPC. To start in Python, you just install your tooling, gRPC tool. There is a nice documentation online that in gRPC.io, that there is a quick start that you can use as a reference to use different kind of programming languages. And its actual documentation is very nice. So when I install all the tooling, I can use a command line, in this case, pass here, where I target my protobuf file that I just showed, the stock proto file, stock market proto, and also Python do some code generation. And here in the folder, the Python client project, there is all this code gen here. I'm not going to go in detail because there's a lot of code generated for me. But it's nice that the tool does it for me. So now I import the module of my code gen. I create an instance of my channel targeting the endpoint of my service, which is the C# running. And then I'm going to call the service. I'm going to create the service tab, passing the channel constructor. Then I do a call using the Microsoft as a ticker. But actually, I'm going to skip this simple call, and I want to do a streaming demo. In this case, I'm going to call the get stock market stream, because I think it's very interesting how we can leverage stream capability from a service using C# and a Python a Python project. So this is the project I'm going to run. They're going to call this service endpoint. I'm going to print in the console my price as a stream. So let's call this guy Python here. This is the Python project. I'm just going to call Python and the client API. And now I'm going to start to stream here on my console the Python library, and you can see that this request here. So in this case, there is a stream channel open on the server side that feed the stream to the downstream Python console app, which is, I think, is quite cool. All right, so let's go back to the slide quick. So in the demo, we saw the unified communication. So gRPC support 4 types of communication channels. The unified communication, where the client sends a single request to the server and get a single response back, just like we saw, just like a regular function. Then we have the streaming, server streaming, where the client sends a request to the server and get a stream to read as a sequence of messages back. So the client will read from the return stream until there are no messages available. And what actually is very cool is that gRPC guarantee message ordering for the individual RPC call. One option that this is the demo was showing in the REST. The traditional REST we have like a large data to return. The classic approach would be to include the array of items into a serialized object, right? In this case, all items would be had to be generated before the request can be returned, which can have like a high resource consumption. But in addition, also the payload size can easily grow. So that's when I demo the pagination kind of approach, right? Streaming here fit quite well as solution. Then we have the client stream, the client streaming, where the client write a sequence of messages and send them to the server. And when the client is finished write the messages, you wait from the server to a response back, right? And also in this case, the message order are guaranteed. Streaming really fit quite well in the streaming communication base, fit well in .NET Core, especially with the lately introduced async enumerable interface, which we can leverage to process asynchronously and blocking the stream until there are no message to process. In the get stock market stream in the slide, and when there is the stream defined as a part of the communication type, we have the iService stream writer argument that we can access to write on a downstream, in this case to the client, using the write async. If it were like a client, there will be an iAsync stream reader that will be used to read the downstream up to the upstream. And of course, you know where I'm going now next is the bidirectional streaming communication, where both client and server send a sequence of messages using a read and write stream. And what is cool is that the two streams operate independently. So the client and the server can read and write in whatever order they like. So for example, the server could wait to receive all the client messages before write the response as a stream, or it could alternately read a message, then write a message. such as like sort of like a ping pong pattern, or any sort of combination that you can use using a read-write approach. And also in this case, by the bidirectional streaming, the order of messages in each stream is preserved, right? While the stream can operate completely independently and in a no blocking fashion. So the pattern we talked earlier, the chatting pattern, REST, and in general in distributed architecture is, is called an anti-pattern. And so the chatting style is used when API in which the client need need to place and run multiple requests in order to receive all the data that it needs. But on the other side, with the stream capability, like in gRPC, it's possible to leverage, the stream capability, also the bidirectional channel between the endpoint, so messaging can be exchanged real time without pooling and all the extra overhead introduced. And the streaming allows, what it does, it creates this long-lived connection between the sender and the receiver, over which multiple messages or frames can be sent asynchronously. So multiple streams can operate independently over one single connection. And that's where, the key here is the HTTP2 support that give us multiplexing that allowed, multiple gRPC call to communicate over a single connection without the extra overhead of disconnecting, reconnecting over and over again, and this really remove huge extra overhead compared to the traditional HTTP forms of communication. And in addition, the request multiplexing allowed also multiple parallel requests for data. So it's now possible using multiplexing to download or upload, for example, multiple files concurrently over one single request. So let's demo the streaming now. So back in our code. So the server is running. So the service here, we have our service. So we saw the single call. Now we're going to get this get stock market stream. Now this is defined our protobuf, and the only difference that we have to do to enable a stream capability communication type is add the stream as a keyword here. Okay, that's all. At that point, the code gen it generated for me the method that enable streaming capability. In this case, is a client streaming capability where actually the server stream back to the client downstream and access the server stream writer stream. So when this call is executed, I can access the response stream and write downstream to the client the stock as a stream. Okay, so the client side here for this service is our, the example shown earlier. We create the gRPC channel, the same pattern. We use the service client code gen, passing the constructor of the channel. And for this demo, I'm going to cancel the streaming after 5 seconds, just to demonstrate how easily can be an operation canceled. Then we have the, we're going to call the get stock stream here. And from the replies, we can access the, sorry, back a minute. Okay, we can access the response stream, read all the data synchronously as a stream, no blocking with our synchronous for each loop, and print in a console the result. Okay, and remember that this is going to stop after 5 seconds. So the stream client here is our project. I'm going to run the project here, and as soon as run, you're going to see going to start to process the stream asynchronously. Streaming. Okay, got stuck here. Sometimes it's stuck, so let's run it from here instead. Sorry about that. Okay, All right, so we have the streaming now that run all the data that come from the upstream, the service, and then it stop at the 5 seconds. You see the stream is being canceled, and that's actually quite nice to have this part of your tool set to be able to cancel easily a request as a stream with a cancellation token. So this is the streaming cancellation. The streaming from the server. The bidirectional is a little bit more complex. So in this case, we have the code on the server that gets stock stream actually both bidirectional. So having a constructor here pass an async stream reader, get a request stream, and this is going to use to read the service used to read from the client stream. So the client going to push a stream of data on the server through the stream here, the request stream. And then the server stream, the response stream, the server use actually to write back to the client. So in this case, I have a thread running, which start to write to the client a series of data as a stream, okay? I use the channel here, sort of like to mimic a producer-consumer pattern. So I'm gonna write to the channel that is going to be passed in this asynchronous for loop here, and then send back to the client in the response stream. And then the server side is going to start to read actually the stream coming from the client, and which is going to send requests for different symbol. So what's going to happen here, we have the server, they're going to start to send a stream of data to the client, and the client, after a little bit, they're going to send a stream of data to switch the type of symbol data that the server should send back, okay? Then we wait for all to stop here, which pretty much is for all the stream to complete. And here is the function where I read from the stock server ticker, produce the data, and pass to the channel, which is then passed up here, right to the client. Okay, so the service is already running. Let's see, this is the bidirectional. So let's run it. Okay, now the client already start here to write the request received from the server, but here you can see how the server will log also that receives different requests. So the request that the service is receiving actually is a stream from the client, and here is the stream the client received from the server. So you have two streams that run independently and asynchronously, and they are, all the order are preserved, which is quite nice. Right, let's stop the client here. So we demo the streaming from server to client in the bidirectional. Let's go back to the PowerPoint briefly here. I want to talk a little bit about the performance in this case, which is yet one more reason why you might switch to gRPC. But the faster is interesting, but there is also, the resource consumption is also reduced to minimum. And this is because protobuffer use this binary format, which is very much is more compact than a text space like JSON. And this reduction of size make your code run faster, but also have less CPU consumption for the serialization or the serialization of a more compact format, which means also less allocation, which means also less GC generation and better performance. In general, you can see from the slide, from the chart, the orange is the protobuf, so the smaller is better in this case, which means take less time, which is faster. And the payload size is about 8 to 7 times smaller with less CPU consumption. In a solution, I'm not going to run it, but if you download the code, there is a benchmark project. They run the exact code that they use to create this chart in .NET Core and to make all the measurements for you that I rendered here. But so clearly, protobuf is the winner about size, which is about from 77, 80% down to 66 when there are larger payload. And this really improve the performance, but also reduce the network bandwidth utilization and as I said, less GC generation. So the other demo that I want to show is that how we expose gRPC to the browser when actually currently is not supported. So this demo use Web API as a gateway. In this case, just for fun, I use the WebSocket SignalR that you use to communicate to the gRPC server is running, which then gonna send back a response as a stream of data and output on the web page the stream as a data. Okay, so we are our service still here running. Okay, so the service is exactly the same that I was using. The application is the web app. So interesting here in a startup, I had to define actually that I'm going to use gRPC in this case as a client, right? So in a startup of my web app, I'm going to pass that gRPC as a client, and you can see I reference the type as the service gRPC service client, the target endpoint of the service that currently is running in the background as my console app. And that's pretty much what I have to do. And here below, I define that I use, SignalR. This is not talk about SignalR, but just to define where my hub is enabled here. So that's I have to do gRPC as a client, okay? So the SignalR hub here expose, well, I can access my service client, my gRPC service client, part of the constructor using dependency injection because it was defined on my startup. And then I have the stock market stream here that is going to read the data as a stream from my service that you're going to call the stock market stream service, and then using the asynchronous for loop here, read the data and then push the data in a text format to my writer stream, which is in this case my SignalR WebSocket. And the JSON file is down here, which I enable the SignalR connection. I use the stream connection that call the stock market stream, which is the method that I define here. There is this mapping method name matches the name of the JavaScript file, of the JavaScript name. And then I subscribe the stream using some sort of reactive approach here. So when the SignalR, the WebSocket receive the message here from my stream, you're gonna populate the web page. All right, let's run the application here. So this is my survey running here. And I start stream, so my SignalR start to read the data from my stream. You can see that there was the response log here. And now I have a stream channel open that communicate from a web app using SignalR that open the client channel to the gRPC service and read it as a stream. All right, so that was cool. So weakness, briefly, there are some limited browser support, again, because gRPC is built on top of HTTP2, which not all the browser supported yet. Probably, I can see in the future that's going to be something that's going to be part of the browser, but currently is a little limitation. However, it just demonstrate in the preview code, we can use some sort of Web API gateway using Web API or SignalR as I use to communicate with the backend gRPC service. So it's a limitation, but there is always a solution. The other limitation is that it's not human readable, like can be a JSON format. Is a trade-off. gRPC use protobuf as a binary format, which is smaller, faster. However, it's not human readable. So if something that you have to use there to consider this kind of limitation. The other thing, I think I'm out of time, so I'm not going to run this demo. I'm going to just show the code here that gRPC use protobuf as main protocol control base to generate the protobuf However, and this is great, especially when you communicate from different platforms and different programming languages. However, if your service and client or service are both in .NET and you don't want to use or reference any protobuf, you can do all using a code based approach, using a declaration based, like attribute based. This is very similar back in the day in WCF. The only thing when you create your message type is that you have to pass the data member with the order because it's still order based. Okay. Not gonna run the demo. The only thing that I want to show here is that the project is up here inside the without protobuf, and the only thing that you have to pass here when you can create the gRPC is actually pass the add code first gRPC, which you will generate the code on the fly. It's going to be penalty to the first time code to do the code gen, and that's it. And the client instead is going to create the channel and then create gRPC service rather than using the code gen gRPC service client past an interface, which is simply the concept they want to use to communicate between the client and the server. But that's pretty much what I want to show here. You can bypass the use of the protobuf file, just all in one, all in code if you want to. All right, that's all. To wrap up, I want to show the fact that the different kind of communication technology we have available today from the REST, which is great for pure web apps and crowd operation. SignalR for multicasting web messages. I demonstrated SignalR earlier. GraphQL, I don't have a great experience in that, but it's great for querying a large data set. And then we have gRPC now, this new tool to have in your tool belt that supports streaming support, very low resource consumption, cross-platform, and lightning fast. I love gRPC performance. So to summarize, cross-platform, very fast, efficiency for microservice architecture for communication with their speed are critical component, and especially for serialization. I have in the past issue with project that to serialize a big JSON data and have a spike of CPU consumption. gRPC can reduce that like by 80%, which is phenomenal. And here is my contact, Twitter, the theory case, my email, and this is the link where you can download all the source code I demonstrate in this presentation. And now I open for question, if any. Otherwise, I'm going to put the slide here with my link. Any question?
Awesome. Thank you, Ricardo, first of all, for a very, very interesting session. There are actually quite a few questions, and to those people who have just asked new questions, I'm not sure we can cover them all, but still, we'll give it a go. I'll let you choose. I have topics around coding, architecture, serialization, connectivity, and security.
Oh, wow. All sexy for me. Well, let's go to architecture and coding first. All
right, let's start with coding first. Probably a yes/no question. Is the gRPC client class thread safe?
Well, yes. So in short, yes.
All right, that's an easy one. What would you recommend for building proto files and to send data classes with many properties over gRPC? Should that just be duplicated in the proto file, or is there an easier way?
You can proto file can reference other proto files, right? So I probably break apart all the proto file that you want to use in different files and use that to manage the different messages and services. I don't know if that's part of the question, but you can create your own NuGet package. So different programming languages can download the NuGet package and reference all the proto files you prepare. So it's always up to date with the latest version. So you can use that and keep the code gen up to date.
All right. One related to that maybe is how would you do contract versioning in gRPC?
So this is I didn't cover this in this talk. That's a good question. So protobuf is ordinal base. However, the order matter, but you can miss some number, and there are also some keyword in a protobuf file that you can use for tell that that's going to be numbered, going to be used in a different version, or that's for future compatibility. There is a library provided by gRPC. I forgot the name. It started with M. I think it's a Mesat. I forgot. I can probably find out. But there is a library that gRPC provide to make versioning easier too.
All right, cool. Shall we switch to serialization maybe?
Yeah, sure.
Have you ever used message pack instead of protobuf, or does that not work with gRPC?
I use that now in a gRPC context, so that will be interesting to use. Now, saying that, this is a good question because gRPC use protobuf as default, but does not prevent you to use your own type of serialization. So I would say that yes, you can replace it, but that's based on a documentation that I read, but I never tried.
All right, perfect. Then another one, in a stack of microservices with GraphQL, does it make sense to use gRPC for the inter-service communication and leave GraphQL, for example, for just the external calls?
It does. However, I think that you will be, I think it does. I was thinking you probably will lose the stream capabilities, but relatively, not completely, because depending you build your GraphQL API, you can still use streaming in the back. So yeah, I think that will make sense. Yes.
All right, cool. Are you up for two more maybe?
Yeah, let's do it.
All right, around that long-lived stream, is that a real-time stream, or do you have to actually call it to receive the stream? And also, when it disconnects, is there a reconnect capability there?
Yes and yes. So yes, it's a real time, which is very cool, and it does reconnect for you. So I didn't show, there is a lot of stuff I could show here. This is more low level, but yeah, you can. There is a policy that you can pass in gRPC, and when you create your both the client or the server. In this case, I would think that mostly going to happen on the client side, and you can pass a policy how to handle reconnection if the connection drops. Very good question. Yes.
All right, cool, makes sense. There's a couple of questions around using TLS and SSL on setting that up, but I guess those are practical ones that people can probably reach out or maybe find on your blog and other resources. There is, however, one interesting one. How would you go about authenticating gRPC services?
So it support both. So if you build an API, web API is a gateway, of course you can leverage that. However, APIs, gRPC is very secure. In the source code, I have actually did not demonstrate the code, but I think it's somewhere here where you can pass even certificate. I think you can see my code here, and also authenticate. Also very easy to integrate on the gRPC side. I wish I have a source code, but I can tweet the link about it. But yeah, it's very easy. The Microsoft really did a fantastic job to make gRPC easy to integrate with .NET Core, and even authentication is very easy to inject in your code.
All right, cool. Thank you. I guess that's pretty much it. There's one very, very big question that I think warrants a session on its own, which is around using gRPC over a service bus kind of architecture. So unless you can maybe answer it in a couple of sentences, it may make sense to just reach out to Ricardo. But I'll leave that.
I'm very friendly. So send me an email and a tweet. I'll be happy to answer. This actually probably it'd be interesting actually if I can write a blog about architecture, how to integrate gRPC in different architecture. But yeah, please feel free to contact me. This is my email, tricardo@gmail, and my Twitter. So and yeah, download the code and play with that.
All right, cool. Well, thanks again, and also thanks for handling a large load of questions as well. People who still have an open question, I'm sorry we didn't get to it, but I guess we'll wrap up here. So let's switch back to my screen.
All right, thank you for having me. It was a pleasure.
Yeah, thanks, man. All right, for those of you who have joined the entire day, thank you. For those of you who joined just one session, and I know some of the speakers have been here for just one session, I want to thank you for attending. I want to thank all of today's speakers and tomorrow's speakers as well for joining us today. And if you want to join us tomorrow for more sessions, we'll be back same time, same place, just a different date. Thanks again for joining, and we'll see you tomorrow.